Hello, just a quick note, we're going to start about 10 minutes after time because people are still registering and getting in. So yeah, if you want to get something in between, we have more 10 minutes before we start. Thanks.
Ah. Oh.
That's good.
It's working.
Yeah, thank you.
Thank you.
You're welcome. And we're recording, so
Okay. Oh, are you like our room?
he is. You're the room manager?
Oh, okay. Oh, yeah. Okay.
We just need 2 more minutes.
Okay. We'll get started in 2 minutes.
Yeah, it's 5 minus 3.
Do you need audio on your computer?
Yeah. There's a 1 minute up here, right? This is one of those like quiz questions. You've got 5, 10
Yeah.
minutes.
Oh, these are nice.
Oh, is there a 1 minute?
Yeah.
There as well?
Yeah.
I'll take that.
In 60 seconds, you can use it.
That's right. Do we have any practice? See who goes first? Yeah. Yeah.
Oh, it's right there. Uh-oh. Where did it go? No, I just plugged my computer in.
You might have to do the thing you did last time again, the display settings.
Oh.
Oh, you
Yeah,
should give those to
Okay, there's some Tacker. Good.
Billy.
Hello.
Can we?
Have any audio?
It does not.
No.
No. Okay. Well, I had this figured out.
Do the display setting again. Do the same steps again, because it is
Yeah.
the other screen right now.
Where'd it go? Is it over there again? Oh, I need to plug it. Okay, hang on. Why is it over there?
Because it's the other screen. So 2 screens, it's the other
Oh,
screen. So
okay.
you have to do the display settings
here.
and switch it to the screen.
Okay. But
Yeah.
Well, luckily we don't have 501 people to see now.
yeah. We had it.
We almost have it.
Right? They're as peaceful. I'm going for peaceful.
Don't plug it in yet again. Switch the display and then plug it in and see what happens.
Well, I can't. It won't detect the display until it's plugged in. I wonder if this is what's screwing. If plugging. I don't know why it's doing that. Okay. Yeah.
Please hold while we have technical difficulties. For our next off script, we will be dancing. No, we will not. So did everyone have a good flight or drive? Yes, I'm going to entertain you. Julia drove. I know y'all flew. Anyone on a boat? Ildiko, sort of. Did anyone take a train? Hey, we got some trains. Did anyone swim? Walk? Yes, yesterday. What was that? I did not ride the horse here. I have been known to take meetings on a horse. Just saying. I've never done the board meeting on a horse. I have done the TC meeting on a horse. Sorry, Gotham. Oh yeah, I have my headset on. We just keep going. Sometimes I do include the horse. I just have it on speakerphone.
Thank you. All right, we are in business. All right,
Are we ready?
we are ready.
I don't have to-
Salem set us up.
All right, I no longer have to entertain y'all. Okay, I do still have to.
More about open source ways.
I am willing to take donations to make the pony open source. How's that? Okay, so welcome everyone to OpenInfra Days North America 2025. This is our second OpenInfra Days. Last year we were hosted at Indiana University in Indianapolis. Was anyone there? Nice. Excellent. For those who don't know me, my name is Amy Marish. I am one of your MCs for the weekend.
And I'm Sash Kosh, and I'm the other MC for this weekend.
All right, so we have a full day of events. Yes, we know we're starting a little late. We'll catch up eventually. And we're going to have the keynote starting in a minute, but we want to thank our sponsors. There we go. Our headline sponsors are Rackspace. Thank you, Rackspace. Z-Converter Cloud. Spotlight sponsors are Jetstream 2 and Lightbits. Our coffee sponsor, thank you very much, Pure Storage. Our diversity sponsor, which is near and dear to my heart, Open Metal. And the OpenStack birthday sponsor is Red Hat.
And also a huge thank you to all the community members who made this community-driven event possible. So we are very excited to be able to bring this to you.
All right, tonight we are going to celebrate 15 years of OpenStack. We are at Deer Wolf. I have no clue where it is, but it is nearby at 6:30. Spacing is limited, so find me during the day. Part of the reasons why I wore a very findable t-shirt. I have tickets. So if you are interested in going, I have 50 tickets. Come find me. If you pre-registered, find me first. So let me introduce Allison Price. Everyone should know her from the foundation. Oop, hang on. She's so organized. She gave me a speech and everything. We want to get Allison's title right. She is the VP of Marketing and Community at the OpenStack Foundation, and she will be joined on stage partway through by Gerald Bothello, the Senior Director of Cloud Engineering at Walmart Global Technology.
All right, thank you, Amy and Sash, and welcome everyone. I'm excited to be here. I didn't make the last OpenInfra Days North America, so I'm really excited to meet all of you this week. As Amy said, I'm with the OpenInfra Foundation. If you have questions or want to learn more about us, there's several of us here this week, so please come and say hello. But today I want to talk about the $8.8 trillion market that we're seeing around open source infrastructure, what's driving it, and how our projects and how our communities are responding. That said, before I get started, I do want to take a moment. I know Sash called out the organizers, but I think she understated it a little bit because she also is one of them. But everything, all the programming, all the refreshments, all the sponsorships are organized by people in their volunteer time. So I think there's a few of you in here, so stand up, please, and please help me give a round of applause for these people and all of the work they did. I know finding that drink ticket from Amy is really important, but also find them and say thank you throughout the week, please. Another thing I wanted to call out that's really special about the place we are this week is about the impact of the recent wildfires. Not only was this area impacted, but this actual building was where people were offered refuge when they didn't have anywhere else to go. So the organizers made a really awesome decision and used some of the sponsorship money they had to donate to the World Central Kitchen to help those who are affected. I encourage everyone, if you have the means, there's a QR code. This is a great organization who is directly helping people rebuild their lives. All right, so let's talk open infrastructure. So like I said, some of you may not be as familiar with the OpenInfra Foundation, so I wanted to give a brief overview of just what we do, who we support, and how you can get involved. So we support open source infrastructure projects and build communities around those projects to make them sustainable and make them suitable for production environments. OpenStack may be the most familiar project that you see on the slide, but we also support Kata containers, Starling X, and Zool, which are all critical pieces of infrastructure software. And we have presentations this morning that will go deeper into those technologies. So I encourage you to learn more about them and how you can get involved or use them in production. We can't do any of this, the foundation, all our communities, and even these events without our partners. So we are supported by organizations throughout the world, many of whom are also sponsoring this event, that are gold, platinum, silver, and associate members who really contribute and further the mission of the OpenInfra Foundation, which is to build and strengthen these open source communities so they can be sustainable and they can serve the organizations who rely on them day to day. What all these organizations are made up of, we're not just organizations, we're people. Every single person in this room has a story, and actually there's a podcast now called My Open Source Experience that Ildiko Vangsha leads, where individuals are able to tell those stories. And something that I'm super proud of is that our community is made up of over 110,000 people that each have a really unique story, really unique contributions, and really unique part of the community that no one else can replicate. So thank you all for being part of this community, because we can't do it without all of you, and everyone brings such a unique perspective that makes all of this work. And when I say work, what have we done? Let's put some data behind it. So like I said, OpenStack is one of the more familiar projects, and we're also celebrating 15 years this year, which is very exciting. So there are some activities out there where you can kind of talk about how long you've been in the community and what your contributions have been. But together, this global community have contributed over 600,000 code changes from over 10,000 contributors, hundreds of organizations, and it's become one of the most active open source projects around the world. So this is impressive. This is exciting. This momentum is something that as a community we're really feeling from an adoption perspective that we'll hear from Walmart in a little bit, from a contributor perspective that we can see in these numbers, and even from an ecosystem perspective that you can hear out there when you talk to our sponsors in the hallway. What it really reflects, though, is this overall demand. It's bigger than OpenStack. It's bigger than Kubernetes. It's bigger than all of the projects combined, because there's this demand for open source infrastructure software because of people looking for various reasons, whether it's different cost efficiency, whether it's avoiding vendor lock-in, but they've measured that it's an $8.8 trillion market. So this is massive. This is a massive growth opportunity. It's a massive opportunity for all of us to come together, build software, and make sure everyone's aware of this as an option for their data center infrastructure. Within that, we're seeing a financial market growth for OpenStack as well. So the market opportunity from just last year has quadrupled, or is expected to quadruple, until 2029 to $91.4 billion. So there's a lot of work to be done. There's a lot of opportunity. There's a lot of education. There's a lot of just ways that OpenStack can come and change the world, and I think all of us are part of that, which I think is really exciting. 15 years in, sometimes I remember in 2014 seeing numbers like this, and I was like, okay, sure, it's a newer project. But we're 15 years in, and we still have a massive market opportunity, and I think that's really exciting. But this growth, like I said, it's not just the contributors, it's not just the market, it's also the users. So one user we actually haven't heard from in a long time that, I talked to Gerald a few years ago. I called him, and we were talking about how Walmart's used OpenStack since 2014, and I told him, I was like, well, I'm running into this challenge because people keep telling me OpenStack is dead. Like, and I'm sure, raise your hand if you've heard that, you know? Yeah, me too. And he laughed at me. He's like, why would they say that? Like, we've been using it since 2014, it works great, and we're gonna continue to use it far into the future. So I'm really excited for him to come on stage and join me to talk about Walmart's OpenStack cloud journey and how it's evolved since 2014. Please welcome Gerald.
Thank you, Allison. Yes, we have been using OpenStack since 2014, and I'm here today to talk about Walmart's OpenStack cloud journey. We started in about 2014 with Havana, with a small team, few engineers, few thousands of cores. And our application teams were excited, and we ran our holiday on a few thousand cores, and it was really successful and it really went well. That generated a lot of interest from our application teams within Walmart, right? So as we moved along from 2014, the interest with application engineers and the teams inside increased. So we ended up doubling the capacity every year from like 2014 all the way to 2017, right? So we started to outgrow our data centers. By 2017, we had already crossed about 100,000 cores. Now in today's date, 100,000 cores is small, but those days, I remember there was a 100,000 core club that we had stickers and everything. I still have it on my laptop. And as we kept going, the adoption kept growing within the company, right? So by 2017, as we were growing double the capacity every year, we started to outgrow our data centers. So we started looking at public clouds as well. We started to integrate with some of the public clouds. Moving along, by 2021, we had integrated with public cloud and private clouds. Our private was applications that ran on OpenStack as well as on the public clouds. By 2021, we hit about 1 million cores. And now, fast forward, we are way past the 1 million cores mark. So OpenStack continues to grow within Walmart, and we use it as a mix of between public and private, right? Now, with the scale that we are growing with, you also need to keep upgrading the clouds and be current with OpenStack, right? So with our scale, we found it really important to keep constantly upgrade these clouds. So back in 2014, when we were, if anybody remembers with Havana, it was pretty disruptive. So we had our first holiday, and then we had to upgrade to Juno, and it wasn't very pleasant. So we migrated the workloads, the application teams moved over, and then we went to Juno, and the silver lining is from Juno onwards, it was in place. So it was great, right? But it was still like, it used to take us about a month to upgrade. And there was a lot of hand-holding, there was a lot of cross-team chatter that used to happen. So between 2014 to 2016, we went with Juno and then so forth with the upgrades, and it was slow. After 2018, we started to do in-place upgrades, which was stateless. So you could get the entire OpenStack bits with the OS upgrade, the post configs, everything, and then the upgrades were seamless. Between 2018 to 2025, now we have improved on the stateless upgrades, and now we can upgrade clouds within a couple of days. So like we are talking of the entire fleet. So every year we are upgrading over 1 million plus cores of racks. So as what do we call it? Within a 3-month time frame, we do the entire fleet and we keep going, right? And we do like we skip an upgrade, so we can go faster and we keep current. So it's been great. With these cloud upgrades and the scale, you got to keep automation up to date as well, because the team is still small and you got to manage and maintain these clouds. So we have automation that runs on the control plane or on the cloud management layer, where you can, all the OpenStack components we have self-healing in place, we have automation in place that looks at these components and self-heals them before we land up into a P0 or P1 issue, right? Simultaneously, we look at the hardware layer as well. We have a lot of automation built in on the hardware layer as well, where it looks at the entire fleet. We have self-healing on the fleet. It looks at the components. It takes them out of rotation before the machine crashes so that you don't land up into a situation where the app is just like left hung or it crashes and it creates a P1. So we have automation. We have a lot of self-healing and automation at both the layers where these machines are taken care of seamlessly. They go in and out of rotation. In addition to this, we also have proprietary tools that we have built. We have Galaxy, which we had spoken about some time back. So Galaxy is basically, it looks at the entire fleet and its inventory management, and it gives you a bird's eye view. Within a couple of minutes, you can exactly figure out which part of your cloud is broken or where it has been impacted, and you can go fix it, right? And then we have a bunch of telemetry dashboards that you can look at, like how long was the impact, when was there an impact, or if machines are going up and down, why these machines are going up and down, and all that stuff, right? So that's how we look at the clouds, where we have a whole lot of automation that keeps the clouds up and running and improves the availability for our end customers. And that enables us to keep growing and innovate and keep moving faster, and enables us to save money, which we pass it on to the end customer, and keep managing our clouds at Walmart. We have a talk that talks about rebalancing, a part of the automation, which is tomorrow in the same room at 2 o'clock. And Sukesh and Jimmy will be talking about that, where we showcase how we move our machines, where we rebalance the machines across these cloud endpoints and for the various operations that we run on these clouds. Thank you, and I'll pass it on to Allison.
Thank you. All right, so thank you, Gerald. It's really great to hear the Walmart story, and I've never heard, it's nice to hear seamless upgrades. I don't know, I still have some PTSD from some of those pain points I heard about. So the next part of the presentation, I want to talk about some trends that we're seeing from the foundation that are really driving the market growth I was talking about earlier. And we're seeing this affect not only OpenStack or Kata containers, but all open source infrastructure software. And I'm sure that there will be many of you who have your own perspectives that I'd love to hear about this week. So the first one is digital sovereignty. This one is becoming increasingly important, and it's around, where your data is stored, who has access to it, and most importantly, what laws and regulations may apply to it. But one of the great things that I want to highlight is the open source response to digital sovereignty. And that's something that the flexibility of open source has really provided to be a unique advantage to overcome some of the challenges. And what we've seen, we have a massive footprint of over 300 public cloud data centers based on OpenStack. And that footprint just continues to grow. We learn more about them every month. Jimmy MacArthur here, he talks to users all the time, and we're adding more pins to this map. So if your pin is not represented, please find him and talk to him about your footprint. But we also have a private cloud footprint that's equally impressive, and we're seeing more and more of these come online as well. So one great example is that 9 of the biggest banks in France, so finance, everyone's data should be secure, and there are a lot of laws that apply to that. They all trust OpenStack. They all run on OpenStack, work with regional partners who understand those laws and regulations. And so that's led to a really big increase in some of these partners that we have that have a very regional focus, but those are increasingly important to make sure that we have a response to these laws and regulations. One such use case that I almost included, but this morning I changed my slides. The United Nations actually just launched an OpenStack-based private cloud, and for a lot of these same reasons. And we're going to be talking more about that as a foundation and how they're going to be using OpenStack to protect their data and be as transparent as possible with their citizens. Another trend is licensing changes. So I don't know if anyone heard about the change that Broadcom made in 2023, but it has been impactful. And we used to call it Merry Christmas OpenStack last year because it's created a wave of OpenStack interest that has been incredible. I was talking to a Forrester analyst, and he was like, yeah, we haven't heard much from OpenStack, but then I've been getting truckloads of questions from enterprises around how they can get off of VMware into OpenStack. And I was like, hey, me too. We're really excited to see OpenStack community and our partners really stand up and offer solutions. And one of the really interesting things as we talk to our members that I highlighted earlier, Right after this change, I think we did this survey last April maybe, so we're still at the very beginning. This happened in December 2023. So fast forward 5 months, over 80% of our members had already received an inquiry to migrate workloads from VMware to OpenStack, which inquiry is great, but inquiries don't pay the bills, right? So, but the next impressive thing is over 60% of them had already won that business and made those migrations. And we're hearing more and more of them. I actually have one in my inbox from this morning that they migrated, it was a bank in Indonesia, and it took 4 days to perform their migration, and now they're all up and running on OpenStack. So these stories are just coming out of the woodwork, and we're really excited to see OpenStack not only take an opportunity in the virtualization market, but also see organizations learn how they can actually modernize their infrastructure with OpenStack and maybe even make it a little bit more efficient along the way and ditch some services that they may not have needed. One such user is Geico. It's nice to do an event in North America where most people probably have heard of Geico. When we used this in Korea, I think we had to put a little bit more background on what Geico was. But they are a really massive insurer, and they are working with a partner of ours to migrate workloads from VMware to OpenStack. And we actually published a white paper last September where we highlighted some of their experiences and why they actually did it. Because if you've worked with financial services companies, it takes a long time to make these decisions. And so for them to move on this quickly was really impressive, and it showed how much of a movement this really is. But if you have questions or you even have stories that you want to tell, this is actually happening here this week. So in addition to the open source response, we have an OpenInfra Days North America response. There is a talk, today's Thursday, right? Yep, today. But economics of migrating from VMware to OpenStack. I think that's Ken from Rackspace. Yep, right over here. And so he'll be talking about that in the other room this afternoon at 4:30. And then tomorrow afternoon at 2:30 in this room, Jimmy will be leading a panel talking about going from VMware to OpenStack and what the impact has been on the virtualization landscape. So please attend these if you have questions. But if you have your own story, please find Jimmy or myself. We have a working group in the OpenInfra community that is trying to explain to the entire industry why this move is important, and we want you to be part of that story. So the next one is around security. So security has always been a thing. When you're building your data center, it's a critical, important piece that your end users are worried about and that you want to make sure that your workloads are as secure as possible. But one of the interesting things is, the container hype started around 2016, 2017, and everyone turned to the container landscape. But then we started finding there was a lot of vulnerability. And so there's a lot of challenges in how to make sure that your containers are secure and how to ensure that your entire environment, your cloud environment, is secure, which, as I said, it's not a new challenge, but it is something that you have to think of, and it has to be top of mind. But this is something where Kata Containers has been really changing the narrative. So this is a secure container runtime backed by a global open source community. Ildiko Vangsha, oh dear, 1 minute. That's not gonna happen, sorry. I'm gonna do my best. She's gonna be talking more about it in a minute, but we've seen the hyperscalers turn to it. Most recently, NVIDIA has turned to it. And it's really helped reverse that narrative and say that containers are now secure and that there's an open source community behind the software that can ensure that your environment is as secure as possible. Okay, the last one. I know everyone's probably so tired of hearing about AI, so I apologize. But AI really has fundamentally redefined the requirements for infrastructure, whether it's the accelerated compute you need, all the storage, or even the footprint that you need. But it's not just AI, it's what is your cloud doing? How is your cloud evolving to serve these AI workloads? And one of the things that I've personally found interesting as this AI wave has hit us all in the face is that, OpenStack laid the foundation for HPC workloads. Like the scientific SIG is meeting here this week. It's been an ongoing conversation for as long as I can remember. And HPC laid the groundwork, in my opinion, for AI. A lot of its characteristics are the same, and that means that OpenStack, in particular, is well poised to take on this new opportunity. How big is this opportunity? So Jensen Huang, the CEO of NVIDIA, has a perspective, which is very valid as the CEO of NVIDIA, that this is a $2 trillion opportunity. So, we talked about that $8.8 trillion opportunity. This is a quarter of it. So that's massive. One use case, one trend, is a quarter of the whole opportunity. And so that's something we all need to band together on. And it's actually another working group that I'm leading within the OpenInfra community to talk about how we as an open source community can respond to that, make sure the software can stand up to it, and that we are working together to address it. But we already are. This is great news. So there already are some production use cases, including the fastest supercomputer in the UK, who is working with Stack HPC, which is a really great story that we'll be telling soon in the working group. And another one that I'm hoping to publish next week is that FPT Smart Cloud is an OpenInfra member based in Vietnam. And they have built 3 separate AI-powered use cases using OpenStack. One of the ones I found really interesting was that they have built this ID scanning system for all of the Vietnamese banks throughout Vietnam, and it's 10,000 requests per minute. So their infrastructure has to stand up and do some pretty powerful stuff. And they're doing it at 50% of the cost of a hyperscaler. So that data and all those calculations are actually why I haven't published it yet, because I'm trying to wrap my head around it. But it's going to be really exciting and impressive and really set the stage for what we as a global community can do with OpenStack around AI. Similar to the VMware licensing changes, we have some sessions here this week. We have leveraging OpenInfra and open source Gen AI to address climate change, which I think is Armstrong's talk. That's tomorrow in this room, yes. And I will be moderating a panel tomorrow as well in this room talking about how we as a community can take on this opportunity and address the challenges that are ahead of us. So, TLDR, open source is the way. We're doing it. We all need to do it together, all 110,000 of us, but especially those of us here this week. Let's talk. Let's network this week. Again, there's a lot of us here from the OpenInfra Foundation. We want to tell your story, so please come up to us and join us. This is a link to join us, the community, but find us in person as well. And I'm sorry I went over my 1 minute by a lot, so thank you.
No. Chris has one. Thank you, Allison and Gerald. Next up is our headline sponsor, Rackspace Technologies, with Chris Brew and Luke Repko. They're going to be talking about unapologetic.
What are we going to be talking about?
Unapologetically resolute, a bold leap into open infrastructure.
That's what we are. We're unapologetically resolute. Yeah, we're
Unapologetically wordy.
Yeah, we're going to be talking to you about what we've been working on for the last year. Because a lot of you probably know OpenStack, or Rackspace is associated with OpenStack. If you know OpenStack, you know Rackspace. And so we're going to talk to you a little bit about what we've been doing. Chris is going to kick it off. But yeah, I am Luke. I've been with Rackspace for a little over 10 years. Chris has been at Rackspace for 15. Combined, we got 25 years under our belts of keeping the lights on and our data centers, public and private cloud. Chris is with private. I'm with the public cloud. I run the day-to-day operations. Chris?
I am a cloud architect, so I do designing clouds for customers, helping customers on their cloud journey, et cetera. And Luke and I have teamed up with Kevin and Rackspace to do the next version of OpenStack at Rackspace. So there are a lot of OpenStack solutions that exist in the world that run OpenStack on Kubernetes. At Rackspace, we wanted to, better? Okay. At Rackspace, we wanted to take another approach and run OpenStack and Kubernetes. I know that sounds a little bit weird, but what we're trying to say is that we want to enable customers to run their custom applications on the same Kubernetes clusters that OpenStack is running from. So standing on the shoulders of giants, we could see a future where OpenStack and customers' apps could coexist in the same Kubernetes clusters. The integration of Neutron OVN and KubeOVN spans that networking bridge, allowing customer apps to talk to VMs inside of an OpenStack cluster. Think VPCs. Enabling customers to run their own apps alongside OpenStack in the same Kubernetes clusters allows for unlimited combinations and flexibility. As an example, a database could be running in an OpenStack VM space and webheads running in a Kubernetes pod and intercommunicating between them. A customer could also extend their private IP space into Kubernetes, or vice versa, all using Neutron Magic with Neutron OVN and KubeOVN. By leaning heavily into the OLM model, we ensure stability and reliability in vital core functionality and services that are deployed inside of the Kubernetes cluster. So OpenStack needs Rabbit. Okay, we'll use a Rabbit operator to do that. OpenStack needs a database. We'll use the MariaDB operator to do that. By using operators, we also give the customer the ability to use those same operators in their same applications. It's bridging the two customer application and OpenStack in the same Kubernetes cluster. Overall, the ultimate enablement of customer choice that will allow us to take over the world. As we all know, world domination is always more fun with friends. And as Allison pointed out, there's $8 trillion market we can take over.
A lot of friends.
A lot of friends we could have. Now that we have what we thought was a grand and great idea, how do we make it all work? We looked at the community at large and saw that there were 3 main user personas. We have the developer on one hand who just wants to download something, tinker with it, and play around with it. We have enterprise IT on the other side that requires a more robust solution. CVE scanning and patching for your images. Metrics, observability, monitoring, all the things that an enterprise IT would require. To reach the largest audience possible, we wanted to design a solution that fits all of the user personas. So we have developer, or we have hobbyist, we have IT, we have developer. And we think we did that with our GeneStack Community Edition. Now that Rackspace is reaffirming its commitments to the OpenStack community, we're starting by giving an open source version of our new tooling called GeneStack. So GeneStack is the basis for everything we're going to be doing going forward in OpenStack inside of Rackspace. And now why are we doing this? For the longest time, Rackspace has operated in a two cloud mentality. We have our public cloud, and we have our private clouds. This artificial separation resulted in a massive duplication of effort all the way from development through operations and ending in user experience. This was a terrible idea that stifled innovation and velocity in new products and features reaching markets. We finally understood that, right? We're running OpenStack-ish in our public clouds. We're running OpenStack in our private clouds. Why are we not using the same code base? Why are we not using the same operational tooling and the same user experience? By bringing our public cloud and our private clouds teams together, we can achieve our goal of simplifying previously complex code bases, reducing operational and support costs, and bringing a consistent user experience. Now to share some of our lessons learned, turn it over to Luke.
Yeah, so over the last 10 years or so, Rackspace has been working on OpenStack. We've been working on OpenStack for a long time, but I think at the very beginning of our journey, we internally took a wrong turn. We forked a lot of the upstream OpenStack code bases and kind of went into individual silos. Those silos kept working on OpenStack internally. We kept committing upstream here and there, but a lot of the forks that we had, we maintained internally. They stayed that way, and that's a recipe for disaster, right? Because we lost a lot of code, a lot of feature parity along the way, and it was never a good thing. And so Chris alluded to duplication of efforts. So we had that in a big way because between that internal code base that we were maintaining and then the private cloud doing their own thing, there were 2 separate teams, 2 separate BUs doing this, right? And so we had all kinds of deployment tools like Salt in configuration management, Salt, Python, Ansible, Chef, Puppet, you name it, we probably had it in prod. And so we had to get rid of that at some point, right? So over the years, that led us to where we are now. We have GeneStack, right? So that's what we've been working on for the last year. Open Center, Kubernetes, running GeneStack, running Kubernetes, and then running, let's find my spot here. Running OpenStack alongside of Kubernetes, right, is the whole point. That's what GeneStack gives you. It bundles OpenStack and an easy way to install. It's an easy way to install OpenStack. Okay, and with that, so we, we had to give developers an easy way to get onboarded, right? So we have OpenTofu and Ansible are some of the tooling that's some of the tooling that we've used to help our developers onboard quickly, because there's only a small group of us that have really been working on this in a big way. So for pulling in quick changes, or to enable our developers to code quickly and get releases done, we had to make the lab environments that are building OpenStack, and, our Kubernetes environments with OpenStack installed on top of it, easy and repeatable. So we're using OpenTofu and Ansible for that. And of course, at the same time, while everybody's working on their code, we're enforcing Docs' code, so it's right there in the code base. You go to docs.rackspacecloud.com. You can see all the docs that are associated with GenaStack right there. And of course, we're using SDLCs and ADRs, which is going to help keep us from having the same conversations over and over. It'll take a lot of that redundancy out, and let us innovate at scale, right? So, and so, no more code chaos, right? So public cloud and private cloud, we've already mentioned before that our teams have gone off. We've separated ourselves, and we're bringing each other together. We're unifying our forces, and we're coding together again at Rackspace internally, and we're back. We're back. So that's the whole thing. The statement we're trying to make is that we're back. The rack is back. Yeah. We're gonna start contributing more, and that's what we hope you will see from us. Yeah, and that's about all I have. Yeah, thank you guys. Yeah.
Just a quick link to the documentation and the repo we're sharing out to everybody. And shout out to Ken for his Cloud Mafia's logo.
Yeah.
Thank you, everybody.
Yeah, thanks, guys.
Oh, we're a minute ahead of time. We gave a minute back.
Yeah.
So Rack is back at OpenStack. So thank you, Chris and Luke. And also Rackspace is one of our headline sponsors. So thank you for that. Next, I'd like to welcome DJ Min, from the founder and CEO of zConverter. zConverter is also a headline sponsor, so big round of applause for both zConverter and Rackspace, please. And thank you. And DJ Min will be talking about migrating from VMware to OpenStack. So, all yours.
Let me show you the topic. Can I use?
Yes, you can use this one.
Okay. Thank you so much for giving me a chance to speak with you. I'm the founder and the CEO of zConverter. zConverter is a member of VMware Migration to OpenStack Working Group. Today, I'm going to talk about the 7 essential considerations for successful VMware migration to OpenStack. And the guy on the right is me. I paid for AI. Recently, I had the chance to talk with VMware IT managers who work for a conglomerate involved in manufacturing, telecom, or SI companies. They are all affected by VMware's price changes and are considering migrating 1,000 to 2,000 the virtual machine to OpenStack. I heard some interesting news from them about another price changes for the VMware alternatives, such as Nutanix and big techs. They have adjusted their prices to 80% of VMware's. Due to this, they shared their multi-hypervisor strategy to avoid the sudden price hikes or the vendor lock-in issues. Also, they want to have flexible move in and move out capabilities across the multi-hypervisors and cloud platforms. They emphasize the importance of a virtual machine and data protection during the migration. Also, they want to have the migration drill feature to test the migration process and estimate migration time before actual migration. In addition, they wanted to automate their migration process to eliminate human errors. Let me summarize the 7 key findings or requirements for a successful VMware migration to OpenStack. The number 1 is virtual machine and data protection capability during the migration process. Number 2 is migration drill feature. Number 3 is estimate migration time capability. Number 4, automate migration processes to eliminate any human error. And number 6 is like a flexible move in, move out capability. Number 6 is like a free or affordable migration licenses to migrate it like 1,000 or 2,000, the virtual machine to OpenStack. And the final requirement is they want to have a single migration technology or tool to manage all these requirements. Let me talk about how to meet the 7 requirements. As you work to address all these requirements, we identified the 3 technology gaps in OpenStack: the backup, disaster recovery, and migration technologies. Fortunately, a Z converter has hypervisor agnostic, the backup, disaster recovery, and migration technology. 4 months ago, we launched the OpenStack Z task force team to tackle 3 technologies by leveraging our hypervisor agnostic technologies. This is the primary mission of OpenStack Z project team. Organizations can move in and move out their virtual machines across any hypervisors or cloud platforms. As demonstrated in this demo, OpenStack project will empower OpenStack move in and move out capability across different hypervisors or cloud platforms. Another mission is to protect the virtual machine and the data during the migration process. ZR is our hypervisor agnostic backup format. The first step of migration is the VMware's VMDK is backed up in a ZR format. Non-VMware, such as AWS, Bare Metal machines, are also backed up in a ZR backup format. The virtual machines and data are protected using our ZR backup format in the first step of migration. A second step is to recover ZR backup to OpenStack. We tested ZR to OpenStack migration thousands of times. We guarantee a migration success rate 99.9%. Let me talk about migration drill and migration time estimations. By leveraging the disaster recovery technology, organizations can conduct DR drills, which are essentially migration drills, and estimate the RTO, which is migration time. Let me explain why DR drill becomes a migration drill and why RTO is migration time. Assuming the VMware on the left is a production environment, and OpenStack on the right is a cloud DR environment. For disaster recovery services, the first step is to create a GR backup. And second step is to recover GR to OpenStack. Once this recovery process is completed, the services on the left side and the right side are identical. Let me summarize the features of the OpenStack Z project. The first capability is to protect the virtual machine and the data using GR backup. The second capability is to recover GR to OpenStack. This is migration drill. The third capability is the estimate migration time. The fourth capability, by leveraging OpenTofu automation script, you can automate all these migration process. And the fifth capability is flexible move-in, move-out capability. I'm going to show you in the next slide again. And this is a single migration tool. This is number 6, the capability. This tool will offer like affordable and complementary migration licenses. This demo shows the primary features of OpenStack Z project: flexible move-in and move-out capability across multi-hypervisors and cloud platforms. Due to the vendor lock-in issue, if an organization considers migrating the VMware virtual machine to containers, they might pay over $5,000 per virtual machine migration and spend over a year to complete their migrations. We recommend migrating VMware virtual machine to OpenStack virtual machine first to save time and money. The OpenStack G project will empower organizations to move their virtual machine across multi-hypervisors or cloud platforms. Yeah, we're looking forward to collaborating with OpenInfra community members. For more information, please contact the Austin outside. Yeah, thank you so much. Yeah.
Yes. All right, next up on the stage is going to be our project updates. We will be having OpenStack, Zool, Kata, and Starling X. Julia Krieger is the chair of the board of directors for the OpenInfra Foundation, and she'll be representing OpenStack today. We have James Blair, who is the Zool project team lead, and Ildiko, I'm not trying it, who is representing both Kata containers and Starling X as their community manager.
Huzzah. Perfection. Good morning, everyone. Hopefully I'll stick within the 5-minute window. We'll see. This feels like a rolling thing. Uh-oh, I already got the sign. Anyway, I want to start out by saying OpenStack is the de facto cloud computing platform that's open source. It's an infrastructure platform. And if you're not aware, OpenStack is an open source project for creating public and private clouds. And we know of over 300 public cloud data centers operating in the world. But one of the things I want to highlight is there's way more than just that. If you think about it, there are pieces and parts of OpenStack running in probably every cell site on the planet at this point in time. If you actually work in that telecom industry, it actually starts becoming mind-boggling, the infrastructure footprints, because you can have one vendor's OpenStack next to another vendor's OpenStack, next to another vendor's product, next to VMware. And ultimately, OpenStack powers many of these data centers and high-performance computing data centers as well around the world. And this is the result of OpenStack being one of the most active open source projects that we can think of. We have more than 450 organizations, and I was blown away yesterday when I looked at Garrett and went, we're nearing 1 million changes. It's 945,000 and change. And so if you think about it, this year, we're probably going to exceed 1 million. So I'm looking forward to it. So we've had 15 years as an open source project, 30 releases and counting. And what makes OpenStack so powerful, so sticky, so useful, is that it is built around multi-tenancy at its core. And OpenStack also continues to evolve, but the discussion has shifted. It's not about feature parity anymore. It's about how can you leverage the model and the advantages of it so that you can have your scale and capabilities in a platform that fits your business needs. And so soon we'll have the epoxy release of OpenStack, which will be the 31st release. In just about a month. I think it's scheduled for April something, 6th, I think? 2nd? Okay, April 2nd. 2nd, thank you. And epoxy is what we call a slurp release, which is intended to provide set expectations around deprecation and removal of features. And ultimately, this makes the upgrade experience a lot easier. And this work all goes back to the countless hours from our contributors. And when we think about upgrades and the fear, uncertainty, and doubt that comes with them, it's a powerful force. We have to look at it. We have to solve those problems as they come up. We also have to share the knowledge and experience that we gain in those items. But OpenStack has proved its way. It's proved itself that it's up to the challenges. And so if you have feedback or challenges or want to talk to a contributor, open source only works if we all work together. And so you can find contributors on the OFTC IRC network. You can find them here on the mailing list, and hopefully tonight at our birthday party you will come share your experiences, your trials, your tribbles. I forgot my triple, unfortunately. But please talk to the person next to you, share some knowledge, share your context, spread the word. Thank you. And next we have James Blair.
I'll save the jacket for later. We'll do something special with the jacket. Hi, my name is James Blair. I am the founder and current maintainer and project lead, et cetera, of the Zool project. And if you're not familiar with the Zool project, it is an open source CI/CD system that we basically created to be the CI and CD system for OpenStack. So at the time, there was no system out there that could do what we needed to do in order to test a project as complex and vibrant as OpenStack. So we created Zool for that. It has, over the years, continued its adoption beyond the world of OpenStack because there's nothing that specifically ties it to it. It is a general purpose system. And we're actually seeing a lot of adoption in really completely unrelated communities in the automotive sector, in embedded systems, things like that. Really, Zool specializes in testing large, complex projects and in either the real or virtual world. So it's quite flexible. The latest release of Zool was made on Tuesday. So I updated my slide to that, 11.3.0. I'll talk a little bit about what we've done recently that goes into that and what we plan to do in the future. The overall theme, though, for all of this is about sort of continuing scaling outside of the world that we started in. So we built Zool to be a system for the third most active open source project in the world at the time. As we've taken it to new communities, we've seen new challenges and have scaled it to even larger systems. So let's see if, hey, I can work a Mac. So about scaling Zool, we've scaled it to support even larger number of repositories and even larger repositories themselves. So we've actually, some of the new users of Zool are interested in building, let's say, the Android open source project. I don't know if you've actually looked at that recently. It's 1 terabyte and 700 repositories. So there were changes we needed to make to Zool to handle that. Monorepos, they present their own challenges. Zool is actually, frankly, it's an antidote to monorepos. If you run Zool, you do not need to use a monorepo. It's actually it answers the same question that a monorepo answers, which is how do you coordinate work across different systems. Nonetheless, we have people that want to use Zool with monorepos. Maybe they have a monorepo and then some other stuff. Maybe they're migrating to or from a monorepo. It needs to handle that as well. So those are some of the things that we've been adding to Zool to help support. And also, we've added a new sort of late binding job variable system. It turns out we added this feature to Zool that lets you configure jobs with variables. That makes it very flexible. Some people thought that was a really good idea, and so they put tens of thousands of variables in their Zool job definitions, and we're like, oh, okay, we need to handle that scale better, and we do now. We've done a lot of new things that are that you won't see in the OpenStack world around circular dependencies. So OpenStack very deliberately made a choice that all of its dependencies between changes, that is, if you're upgrading, if you're making a change to one OpenStack component, and then you're making a second change to another OpenStack component, and the second one depends on the first one, that would be a strictly linear relationship, and that's because OpenStack, we always wanted the deployment process to be able to be continuous. Other systems, like embedded systems, do not work that way. They upgrade the entire system at once. And so Zool has actually grown a lot of new features around circular dependencies to handle that sort of stuff. There's another, I'm gonna save some time here and just say that there are a number of improvements around circular dependencies and job deduplication in circular dependencies that are in recent versions of Zool. Sort of continuing the theme of scaling, we have this status page in Zool where we show everything that's happening in the system. That, as you can imagine, that only scales up to a certain point. We got to a point where people were like, you're showing 10,000 things on this status page. I can't just scroll to see them all. So we have a new status page that sort of lets you zoom out and zoom in, depending on the kind of Zool system and the sort of question that you're trying to answer. Things that we're working on and are coming up. So there's an effort to add OpenID Connect integration with artifact and container repositories. So right now, Zool has a system built in for storing secrets securely to interact with external systems. This OpenID Connect-based system will make it a lot more automatic. So you can basically set up connection once between a Zool system and, say, a container repository, and then any Zool job will be able to automatically use that to publish artifacts there. Another effort that is ongoing is what we call node pool in Zool. We're going to delete one of the oldest components of Zool. We call it node pool. That's the part of the Zool system that talks to clouds. We're going to delete it and move its functionality into Zool itself. This is one of those things where that code was very old and doesn't behave like the rest of the system. So it's time to bring it into the fold, and it's going to let us do a lot of really interesting things because of that. So there are a couple of talks here about Zool. One is, if you'd like just an introduction to what Zool is, how it works, and how you can get started with it, then the first talk, Project Getting with Zool, would be appropriate for that. And if you'd like to learn more about this whole node pool in Zool thing and that future work, that is Managing Test Resources and Images with Zool. So the times are up there. And I will now hand it over to Ildiko.
Hello, everyone. My name is Ildiko Vancha. The secret is out of the bag now. So I will be talking about two projects, and I think I'm between you and the coffee break, so I will be probably only 5 minutes over my time. So Kata containers, it is a container runtime, an open source container runtime, and what's cool about this project, if you don't know it yet, is that it creates kind of a fusion between containers and virtual machines. So I like to look at it as an evolution path for both of those technologies. So what it gives you a lightweight container environment, but it actually provides it to you in a lightweight virtual machine. So it gives you isolation through hardware virtualization, which is pretty cool. And the latest and greatest release of Kata containers is currently 3.14. So if you're a new user, go and check out the latest and greatest. And if you're an existing user, make sure that you go and install the latest and greatest. So what kind of use cases would you use Kata containers for? Now, in today's digital infrastructure, I would say everything. Because in today's connected world, cybersecurity is under the magnifying glass for a very good reason. So think about things like AI and machine learning that we already mentioned today. So data and sensitive data is kind of a controversial conversation around AI these days. And there are some data sets that you just really don't want to share publicly, and like health and healthcare data is part of that, or other personal information. You just don't want that out in the public. So when it comes to training those models, some additional layers of isolation and security just doesn't hurt in those environments. Another use case that is really popular is multi-tenancy, which in a cloud environment, you don't really think twice. But if you think about Kubernetes, which is an open source container orchestration platform that was designed to make sure that orchestrating your containers and containerized workloads is a breeze. And someone else will take care of the infrastructure because we don't care. We just want those containers to run. Now that means in Kubernetes language that multi-tenancy wasn't really baked into it from the beginning. But if you're using Kubernetes with Kata containers, then you just get that out of the box. And it is also written in the Kubernetes documentation, so you can go and consult that to figure out how to do it. Now, if you want even more security, there is a sibling project to Kata containers in the cloud-native ecosystem called confidential containers. And what that project does is it brings you confidential computing methods and techniques and brings it into the cloud-native world. And Kata containers is the vessel for this project, which means that if you want Coco, you will have to have Kata. Because Kata is the agent and the whole infrastructure around Coco. And this project will enable and allow you to use concepts like trusted execution environment. So what that means is that your data and process will be secured on the hardware layer if you have hardware platforms that are supporting those technologies. So again, pretty cool. And Kata containers, the community recently-ish moved towards a simplified release process, which means that the community dropped the use of stable branches for the minor releases so that they can put these out way more frequently. And I hope you'll hear how significant that is. So what this means to you is that don't rely on, stable releases. It's not cool anymore. What you have to do is move to the latest and greatest as fast as you can. So in case of Kata, monthly. Because those minor releases will bring you improvements as well as important and critical bug fixes. So again, if you're a new user or an existing user, go to the latest and greatest. And what that means is that for like a week and a half or so, that is still 3.14, but after that it will be 3.15, so I will go after you if you don't install that one at that time. Because it's important for all those bug fixes and important enhancements. And when it comes to the major releases, though, I gotta say that the community is following the more feature-driven method and process for the major releases. So for 4.0, the biggest improvement will be to move to a Rust-based runtime to make the container runtime as is even more performant and just really keep up with the most recent and powerful programming languages. So that will come in 4.0 sometime, hopefully planned for this year in 2025. Now, the other project that I would love to talk about, another 5 minutes I got, hopefully I'm mostly in time. So this is StarlingX. It is an open source, fully integrated distributed cloud platform. That was a mouthful. So what does that mean in practice? In one package, you get things like Linux kernel with the Debian operating system, OpenStack, Kubernetes, and many more open source components and building blocks along components and services that the community designs and develops themselves. So there is some complexity to this platform, but because deploying and running a cloud platform is not simple, and even in one data center, just imagine that you do it in a geographically distributed environment with one platform that you get in one ISO package, and you can download it today from the internet. And the latest and greatest release of that one just came out last week. It is 10.0. So again, reminder, go and install the latest and greatest, even though this one has a stable branch, but still go and install the latest and greatest. Because you get a lot of improvements with that release. For example, if you think about, again, cloud networking is something that is always a challenge. And in a geographically distributed environment, it's even worse. So what StarlingX 10.0 brings to you is, you're probably all familiar with this IPv4, IPv6 fiasco, because again, we are living in a connected world and the number of connected devices just grows and grows. So we kind of ran out of the IPv4 address space. And in an ideal world, the ones where unicorns live, the one that doesn't exist, we would all just jump over to IPv6. We would say thank you to IPv4 and leave it behind. Now, in reality, that doesn't happen. So what that means in practice is that operators and infrastructure service providers just have to be able to support both of these simultaneously. So StarlingX users have been asking and working with the community to implement IPv4, IPv6 dual stack support natively in the platform, which with 10.0 is now available, along with other improvements in the networking space. Further improvements include unified software management. I think Allison was mentioning upgrades and things like that. So now with StartingX, you have one interface to do patching and updates and upgrades to your entire distributed deployment, which is pretty great and a huge improvement. You can also configure whether you want standard or low latency kernel in your environment during runtime, which is pretty great. And you might scratch your head why the heck I have documentation on the manageability slide. Now, that is the reminder to go RTFM, meaning read the fabulous manual. Because StartingX integrates a lot of components that will make the platform easier to manage and provide a lot of functionality for your workloads as well. And the community calls them platform services, but because of the number of those, it just grows. And they have, you know, a lot of options to configure them. Now you have a centralized piece in the StartingX documentation to find information about all these. So go read the documentation and let the community know where it can be further improved to make sure that managing all this distributed environment is going to be a breeze. And StartingX also integrates the Harbor registry, which is an OCI compliant, I'm running out of time, registry. So gives you, again, added security through artifact signing, role-based access control, and all those things. OCI compliant, so you can actually use that in a multi-cloud environment, which is pretty great with other compliant registries. And you can use Kata containers in the StartingX platform. I mean, what more could I say to security at this point? So beyond 10.0, guess what? It's gonna be 11.0. And there will be further improvements, as always, to security and manageability, scalability as well in the platform, along with things like replacing HashiCorp Vault with OpenBOW. Just to, again, going back to working in the open source space together. And on that note, to keep myself mostly on time, hopefully you're excited to meet all the OpenInfra communities and work with them if you're not already. So we have an event called Project Teams Gathering where you can do that. And the next one is coming up between April 7 and 11. It's a fully online event, so it is accessible from all around the globe. Please make sure to go to the link, openinfra.org/PTG, and hit the button register, so you will get all the information about the event. And you can mingle with OpenInfra communities as well as adjacent communities and talk about, you know, release processes, what goes into the next release, priorities, and anything that you have on the mind about maintaining and developing these projects. And with that, I will give the word back to Amy and Sash for some more housekeeping information.
All right, first off, actually it still works. First off, I want to thank all our speakers and for all of you for attending today for our keynotes.
And also a special thanks to SCaLE for, you know, allowing us to work with them to co-locate this event. The venue is great, and it worked out really good for us this time. A couple of reminders for today. We just putting up some scheduled reminders. If you want to scan the QR code, it just takes you to the page with the event schedule. So today, all of the sessions are in this room, which is room 106, and the room right across, which is 107. We have a coffee break right after Amy and I finish, and it's right outside, and that's sponsored by Pure Storage. Then we have sessions till 1 p.m., and we have a lunch break from 1 to 2:30. Please do, you know, go out and talk to the sponsors. You know, they have their tables out there, and also, you know, look at some of the other sessions. And then we have sessions again from 2:30 to 6 p.m. We have another announcement for tonight, so hold on one second. But for March 7th, that is tomorrow, we have sessions in room 106, which is this one, and 212, which I think is upstairs. So definitely check that out. Tomorrow's sessions are from 9 to 11:30. We do have a longer break tomorrow. We decided to do that so you can check out some of the other, co-located events, maybe a longer lunch break, talk to the sponsors. And then we have sessions, forums, and workshops till 5:45. And then we have closing remarks back here at 5:45 p.m.
We were buzzing. All right, so as we mentioned this morning, we have a happy hour tonight at Dear Wolf. You can get tickets for me. But then I was handed these lovely little cards talking about your contribution, if you're on the developer side. On the operator side, how many upgrades you've done, your first installation of OpenStack, and similar type questions, including events related. So if you're not an operator or a developer, but you've come to a bunch of OpenInfra and OpenStack events, you're included as well. When you filled out these forms, which are going to be outside at the coffee break, there's a board to tape them up onto. And then Helena was telling me that we are going to make some announcements and some prizes this evening at the happy hour.
Also, for the schedule, I did want to call out one session. The Scientific 6 session is tomorrow at 2. It's their 10th anniversary, so they're going to do something different this year with some lightning talks and things like that. But lastly, to wrap this up, we did want to thank all the sponsors. So Spotlight sponsors Jetstream 2 and Lightbits, Coffee sponsor, right outside, Pure Storage, Diversity sponsor, Open Metal, and OpenStack birthday sponsor, Red Hat.
And once again, I'd like to thank our headline sponsors, Rackspace Technology and Z-Converter.
And if the sponsors are out here, please do stand up so people know who you are and they can come and talk to you, if you don't mind. Any of the sponsors, could you please stand up? Thank you. So thank you, everyone, and definitely reach out to them and talk to them. Thanks. Coffee break is right outside, so go ahead.
Yeah, check, 2, check. I've worked at AV, yeah.
That was painful.
Sorry. And then we just do left, right, arrows?
Yeah, yeah.
Okay, left, right arrow, okay, okay.
The hard
Yeah,
part of
that's
this
easy.
one was there was definitely reverb off that.
Yeah.
Yeah. I mean, we can just do the one.
We can-
And-
Oh, that's picking up on that.
This is
Yeah,
live.
I turned that one on.
Wow. Okay.
Okay. Man. Yeah. If everyone wants to get seated, we can get going here. I think the talks after us would appreciate if we're on time, so we will try to stick to the schedule. So, yeah. Shall we get, I think we'll just get rolling. So, thank you all for coming to Students in Open Source, the OpenInfra University Partnership Program, Growth and Lessons Learned. So today with me, I have Corey, whose photo has, oh, there we go. I have Corey and Steven, who are both instructors, professors at different universities that the OpenInfra Foundation works with. At the end, we can cycle back to this slide for the contact info, or you can find us after the talk. So, jumping right in, what is the UPP, the University Partnership Program? Well, the University Partnership Program is a collaboration between the OpenInfra Foundation and our projects with a number of universities. We started with North Dakota State University and have grown since then to this lengthy list here. And more recently, we have finally gotten our first university outside the US as an associate member and are working on building out our partnership program with Konkuk University in Seoul. So that's very, very exciting. Woo! Yeah, finally! Our general focus is to get more students exposed to and working on open source early so that they can benefit from all of the skills that they learn working in an open source community. There are benefits to the open source project itself and the general ecosystem. The number of times we've had member companies being like, there's just no one to hire. Well, we're working on that. We're trying to alleviate that vacuum by kind of pre-training students to be able to work in open source because open source is so prevalent in our industry. And we have a web page. Yay! That also happened in the last 6 months. So if you're interested in hearing testimonials from other professors and students, seeing videos that students have put together about the work they've done on various OpenInfra projects like OpenStack and Kata containers, you can check them out there. So, first, I will let Corey go through our partnership with Valencia College and give you perspective behind what we've managed to accomplish and where we're going.
Thank you, Kendall. And yeah, thanks. And I don't think some of you realize how difficult Kendall's job is to get two professors on a stage. I mean, if you flash back to your college or university days, you try to get an appointment with them or grading, and you know, they just kind of, they're never there. They're in committees. Good luck getting your dissertation worked on or whatnot. But yeah, this is, I think, a Herculean feat for Kendall to get us both here. But I want to thank you for your time. And so who am I? I'm actually not new. I've actually been around for almost 10 years. I worked at Oracle. They hired me for curriculum developer on their Oracle OpenStack software. So I actually worked on Kilo back in 2015, and I did get it up and running before the engineers, by the way. Thank you. But I also worked on cloud native, and then eventually that all evolved into the Oracle Cloud infrastructure. But now I'm in higher ed, and so at Valencia we have this, I started a new initiative called the A2I, Academics and Industry, and I bet you most of you thought it was probably artificial intelligence again, but no, I kind of coattailed it off of that and grabbed your attention, and it's Academics to Industry initiative. And so coming into higher ed from 25 years in IT, I could tell there was a big chasm between industry and academics. And so with this initiative, there are a couple of goals here. One of them is to address the big 4 skills that I keep receiving feedback from mentors and students that they're lacking in 4 skills. They're lacking in Linux, they're lacking in Git versioning, Python programming, just to get them into programming, and then containerization and Kubernetes. Those are the 4 skills that this initiative is really focusing on to skill them so then they can be ready to start their careers when they finish and they're graduated. But there's something else that, there's another component of this, and that's the full student experience, or the SX. If any of you have worked in contact center, that you've probably heard of CX, well, this is SX, and this is what it all entails. It entails 4 tenets here. The first one is the curriculum. The students have to have the knowledge, right, to build those skills and then build the abilities. So at Valencia College, we're only into about almost 3 years with the cloud computing program. The first partner we brought on was AWS. They offer courseware and free labs, which is always nice to hear from a nonprofit organization. But we also partner with Google Cloud for their Skill Boost labs as well, and as well as the OpenInfra folks to integrate within one of my seminar courses. We're also in the works of partnering with Oracle Academy. We're going to do some workshops with Oracle Academy, access and to experience multiple cloud platforms. And I'm sure multi-cloud platform in their IT offices there. So that's why that's why it's important to expose them to as many cloud platforms as possible before they graduate and then start their careers. The second tenet is mentorships. And back in about, I think, fall 2023, I attended the Vancouver conference. And there I actually met up with the maintainer for Tempest, and we started discussing about how to get students more involved, being mentored. And so I had 2 students originally mentored with him that worked out so well that we've been doing mentorships ever since. So typically it's around 3 to 7 plus students being mentored. Besides Tempest, they also are mentored by the Manila maintainers. Thank you very much over there. As well as we just started with Stack HPC. If I don't know if anybody here is from Stack HPC, thank you. I have a couple of students being mentored with them on the Magnum project. The third tenet are internships. So we have these mentorships being integrated with one of my seminar courses, but students also want to do internships. So working with the internship office at Valencia College, it's a bit of a more formal process. The students have to fill out activity sheets, they have to do reflections, they also have to work one-on-one with their mentors again. But the great thing about this is that if the student had completed a mentorship, all they have to do is do an internship right after that semester, so they're doing back-to-back work with their mentors, which increases the amount of time that they're actually working on the project. So it goes from 3 to 4 months to 7 to 8 months. And that's what we want. We want them to build a rapport with their mentors. We want them to dig in deeper into these projects. So having back-to-back mentorship and internship really helps benefit the students in these cloud programs. And then finally, just this past couple of weeks, Valencia College, I've been working with my contracts department and legal team, and we can officially say that Valencia College is now an official training partner of OpenInfra Foundation. And the goal here is to have students prepare for the COA, the Certified OpenStack Administrator exam, and then take the exam with Mirantis. Mirantis will still provide the exam, but Valencia College will be able now to officially provide training to Valencia students to prepare for that, as well as adults if they're migrating from another industry. If they're coming from, say, hospitality into IT, they can now get trained and get certified for the certification. So we're trying to build this pipeline for organizations like Red Hat, Walmart, et cetera, for new employees, possibly interns, and creating new opportunities to contribute to OpenStack. And with that, I thank you for all your time, and I'm going to turn it back over to, I'm going to turn it to Stephen. Thank you.
Thanks. Good morning, folks. I'm going to try and take a slightly different view of this. I've been living in industry for too long now. I'm the old guy on stage. And so I argue that software isn't eating the world right now. We're drowning in software, and most of it's mediocre, duplicative, and bad. And I came into this space, like the actual problem statement. So I worked for Microsoft for the last 7 years. It's a second tour there. But what I was seeing 5 years ago was a shocking lack of open source understanding in production. Now remember, this is the new Microsoft. This is a Microsoft that actually uses open source throughout all of the infrastructure. And there was still this set of bad dependency decisions being made along the way. I'm also seeing kind of that, I think in a world where anybody can be a programmer with very little training, all of a sudden we're losing the software engineering skill set that actually allows you to deploy and develop at scale with a societal impact. And that's the problem I started to set out to do. And then we've got the, whether you call it sustainability or maintenance or any of the other words that get splashed around here right now, we've got this growing problem with how do you maintain all of these things. So my aha moment was, well, all of the well-run's the important words in that sentence, open source projects that I've been close to for 30 years now, 35 years now, they all have exceptional software engineering skills. And what if we created a course where we gave them, students the basics of software engineering, the basics of open source, and the basics of IP? Because if I grew up in Toronto, if you're an engineer in Canada, you take a half-term course in intellectual property for engineers. So what if we combined all of this and gave them a student project in an active open source project with a mentor? And that's kind of what kicked this all off. Semesters of Code was up and running. The initial experiments, I ran 2 classes back 2 years running at Johns Hopkins in the computer science department. And the interesting challenge, we had 20 students the first year and a collection of about 5 projects participated. My challenge on to my mentors was, you need to give me 2 mentors for your open source project. That's for resilience. And at least 5 student projects kind of thing. And so we ended up with a collection of projects. We got 20 students through. The second year we ran it, because we were still running under COVID protocols at this point, this has been up and running for 4 years, I might have quietly slid 20 more students from University of Galway onto the back of this. So what was a morning class in Baltimore was an afternoon class in Galway. But again, we get to the end of this, we've put 60 students through their paces. We guessed that it would be 60 to 70 hours of student time over a semester. It turns out it's closer to 80. But we were worried, the mentors and I, as we kind of wrestled with this, because this wasn't going to scale properly. It wasn't going to scale on me as instructor in front of a classroom to try and tackle an industry problem. It wasn't going to scale in the curriculum, and it wasn't going to scale on projects either. Word on pedagogy. I walked into this in a reasonable way into the first class. My wife is a school teacher and beat into me the basics. But the thing you start to learn is, I came across between the first and second iteration of the course, Jean Lave. She's an anthropologist just up the coast at UC Berkeley, and I think she's still publishing and probably emeritus now. She had this concept of legitimate peripheral participation. That link there, I'm assuming the slides will be available, points off to the one book. It's a heavy lift of a book to read, even though it's a very small book, because it's a book written by an anthropologist for other anthropologists. But there's still that idea that it all comes down to apprenticeship and mentorship. That's how people learn. And then at the same time, I discovered Carl Wiemann's work. He's a Nobel laureate physicist. He's at Stanford. And they discovered that there was this enormous problem that as the graduating class stepped into the graduate world at Stanford, they didn't actually know how to do physics. And so the physicists, being physicists, came up with experiments on students to figure out what are we doing wrong, kind of thing. And again, what they learned was if you restructure a class into give them the reading the night before and then force them into teams of 4 or 5 and give them problems to solve while you walk amongst them, you actually end up in they teach one another better than anybody that's experienced can teach down to their level. And that moves the whole bell curve to the right, and it holds it to the right for a longer period of time was the interesting thing they learned. Around this time, 2 years ago, I got to go to Carnegie Mellon. And there, what happened, if you'll kind of wind that calendar back a couple of years, we hit up that bad bump in the economy. There was CMU students were losing their internships. So the university cobbled together an internship program for a number of them. And I was invited, I was told by the person who runs software engineering for undergraduates there, this looks like what you do, can you come and do it here? So we went and we built an internship class. This was a dramatically different environment. The students, it was an internship, so we had 20 to 40 hours a week of their time, not 80 hours over a semester with 4 or 5 other courses banging for their attention. And we ended up in a situation that the real professor, remember, I claim to be adjunct. What that means is I am a lowly paid instructor in this world. But the real professor said, look, all of software engineering is about communications. So we're going to force the students into teams of 5. And that's when I got to meet Kendall. And so Kendall was really supportive and came up with a set of projects for us that summer where we forced the students into teams of 5. And it's just a remarkably different outcome. Over that 12 weeks, we had them presenting to us at week 4, week 8, and then the final presentation, and watching their confidence go up. Because again, the only rule was everybody presents. So your team of 5, every one of you is going to spend 2 or 3 minutes talking to the class kind of thing. They still had 2 mentors for a large project now. And this was a situation where, sorry, I should check my time. This was a situation where they were tackling big work on OpenStack projects, which was really interesting. And we ran the course one more iteration last summer. And in running it last summer, some of the things that changed, we ran it out of CMU in Qatar, in Doha. And same thing, but we added one more team, so it was 25 students kind of thing. We're still seeing excellent outcomes. Even with the restructure of the class, instead of a 12-week summer semester, they normally have a 6-week semester, and my mentors pushed back. Sorry, Kendall's mentors pushed back and said, we can't do anything in 6 weeks. And so what we did is we ran the classroom in 6 weeks, and then we added 4 more weeks where the kids went remote. And so they had 10 weeks, and the mentors felt that they could still work with 10 weeks instead of 12. And again, this was fascinating because they learned to trust one another in the 6 weeks together, essentially doing daily stand-ups and getting work done. So when they hit the ground and they all scattered home for that next 4 weeks and suddenly they were all on Zoom, it took them a day or 2 of rockiness, and then they hit the ground running and kept going. And again, they turned in phenomenal work. One of the things, again, this thing about mentorship and near-peer mentorship, there's a paper reference there that's kind of interesting. And as much as I hate the discussion of boot camps, because the world doesn't need yet another team of JavaScript developers building websites, in my very biased opinion, the thing that was fascinating was actually seeing the near-peer mentorship work. That was craziness. They brought themselves up. The one OpenStack project was, the OpenStack project had to manage a Kubernetes cluster. And the student project was to retool all of the error handling because it was a little bit rough from when it was first done. And this was a group of 5 students that didn't know what a container was on day 1. And like week 8, they were still coming through the learning curve of trying to get to a stable environment that they could test and build on. And they were panicking. And that, we also coach the students. We have a little coaching meeting every week, and that falls into one of two things. One of them is, you should really talk to your mentor about that right now. Don't wait for the weekly meeting. The other was, it'll be okay. Those are the two flavors of meeting you have. And we got them through this last bit. The reason all of this is exciting to me is going back to that original problem. Peter Nauer wrote a paper back in '85 called Programming is Theory Building. And at the bottom of it, he's trying to tackle the question at the end of his career on why is maintenance so hard? And I think as we go back to my problem that I'm trying to solve in this with software engineering skill is really around the idea, the aha moment. Not only is all learning social learning, but all software is social software. And there's a way to build that knowledge generation on generation into a project. And that's why we're continuing to do experiments. We're trying to run the experiment one more time this year at CMU. And I'm also looking at doing a boot camp in Africa because what we're looking at is non-traditional work. And that's, and I also want to bring summer internships into Microsoft. And so that's the other experiment that I want to do.
So, we got 5 minutes for growth. And also, thank you very much to both the professors, and we have a third one here as well that have all participated. Yes. We also have a number of mentors here as well that have helped bring students into our communities. So we really appreciate your efforts as well. So growth data, and now we wait for the thing to load. Yep, nailed it. Okay. So over time, building these partnerships have started to keep track of how many students we have going through these programs, and it's really exciting to see these numbers get higher and higher and being able to add more universities onto the end as we actually have students go through these programs. So I'm really excited to actually have data to show, and I do plan to have like number of patches pushed and that sort of thing as well in the future. But it is really interesting to me also to see how many students we've had work on not just OpenStack, but Kata containers as well. And I do hope to build out the program further and include StarlingX and Zool as well when we have contributors from those communities that have the time and willingness to mentor, because it's definitely not an easy thing, and we really do appreciate all of the time spent on that. What else do we want to do? Bring in more universities, especially ones not from the United States, because open source is global. The ecosystem that open source is built in and influences and impacts is global. Students everywhere should be learning about open source, and anything that we can do to bring more students up to speed before they go into the workforce is incredibly valuable for the entire world and the whole open source ecosystem. So I have conversations going with a few universities in other parts of the world, but how can I better work with non-US universities? Obviously, like, I went to school in the US, so that's the scope of my familiarity, but I know that things don't work exactly the same everywhere in the world. So if you have any ideas or know universities in other parts of the world, please come talk to me after. I would love to meet you and be introduced to them. I also plan to have a form on that website that I introduced at the very beginning of the presentation to kind of collect and collate these conversations in a more organized fashion, because right now it's all super organic where I just randomly get introduced to people, and I would like that to be more discoverable and for me to not be a bottleneck. So that's another thing that I am going to try to build out in the future. The other thing I wanted to mention quickly in our last minute, and then maybe we can have a question, is the FLOSS mentoring group. We actually have a presentation on Saturday, well, a panel on Saturday, talking about using mentorship as an on-ramp to open source contributions. So if you're interested in this topic that we've been talking about today, please come check out that panel. It is also an open group that meets like monthly usually. So if you're interested, we have a Discord, yeah, ish. We all have day jobs is the problem. So if you're interested in joining that conversation and bringing your own ideas, we really would love that as well. So please get involved. And questions, can we have one question, Julia? Does anybody have a question? Oh, 1 minute, yeah, we did it. Yes, Jay.
So I've done some of this through other programs like MLH or Outreach in the past.
Yes.
If we have a qualified candidate come out at the end of that,
Yeah.
that we don't have a home for,
Yeah.
what's a good place to like maybe get them into this pipeline at a later point? Because you said there's lots of people looking, like, I mean, I don't want to just throw them at a jobs board because you almost have to mentor someone
Yeah.
how to find a job.
Yeah, that is, okay, so I'm gonna restate the question, assuming we're recording. So when a student goes through one of these university programs or outreachy or a similar mentorship and open source program, and they come out the other side and they're qualified and they're ready to get hired, where do they go? Well, we need to formalize that. One thing I have been working on is with companies like Bloomberg, we have had them come in and talk to students and be like, we are gonna be hiring, this is when our job apps are gonna open, and then talk a little bit about how open source is used in that company. So I am out of time and would love to answer any more questions out in the hallway. All right, oh, yeah, sure. Sorry, Jay. Yeah. Yeah. So, yeah, the question is just, do we have experience working with high schoolers? Not yet, but we can definitely take this conversation into the hallway and figure out something. I think that'd be great. All right, thank you, everyone. Thank you.
Always a pleasure. We really hit
Yes,
29 minutes.
we did.
I call those,
That was perfect.
I call those software developers who don't know their IDE. Because like you sit them down in front of an IDE, they can make all sorts of stuff work, but no. No? There we go. Okay. When does this session actually start? At 2 minutes from now, I think? Okay. So I've got a lot of material to cover. I'm going to start a minute early. I apologize for anyone who walks in a minute late. But I had no idea the talk was coming before mine, and it's a perfect segue because this is about social software. If I had known or heard that term beforehand, I would have even stolen it for the slides. But please do. But I'm Jay Faulkner, and I'm going to be talking to you a little bit about OpenStack in the real world. Who am I? Why should you listen to me? I'm an open source developer at G-Research Open Source Software. G-Research is always hiring in London and Dallas. If you're looking for work, come talk to me. We have a podcast about open source called Gross Out, our little outreach podcast. And I've been working on OpenStack, oh my gosh, I did the math out there for the card, and it's been a long time of OpenStack. But I've worked in it in lots of different contexts. I've worked in private cloud, I've worked in public cloud, and I've also worked in primarily upstream jobs like I have now, so I think I have a little bit of perspective, and I've come to a conclusion: clouds aren't real. They don't exist. The cloud's an idea, right? The idea that you can hide the complexities from the people who use the infrastructure so that they can focus on whatever else it is they do best. And I might say business here, or I might say company, but really it can go to any organization, right? And you're always going to have that if you as an infrastructure team or as an infrastructure provider are able to take someone's attention away from the details, they're free to think more about the things that they're really being paid to do to deliver value. So I'm going to ask you to come with me here. The title of this talk is not OpenStack in the fake world, it's OpenStack in the real world. So, you can stay in your comfortable workflow. You can use APIs to get all your infrastructure and not be encumbered by the physical realities, or you can come with me, see the details hiding behind the surface in the unpretty reality that powers the cloud. So you walked in the door, you accepted the challenge, so welcome to the real world. And so, I mentioned that I've been working as a solely upstream developer for a while, and it's very easy, especially for someone who operates it in DevStack more than a real cloud, to forget about all the complexities that you have to really have an OpenStack cluster in a real world. And I'm going to be talking about it from an ironic or a bare metal cloud perspective, but really, the concepts I'm talking about here are going to be mirrored throughout OpenStack, and honestly mirrored throughout any cloud stack, whether you're talking about OpenStack, or some of the other options out there. So let's just sort of go through real quick in the real world what you got to do to go from zero to cloud. Well, first you've got to purchase some hardware, and you got to consider a lot of things. Does the server you're buying have a standards compliant BMC, which is going to allow you to power the machine on and off programmatically and tell it how to boot and do management remotely? Is it going to have any additional charge that you need to pay for a Redfish license or a virtual media license? Do you care about the network? Then, you need network switches that can be automated, and that's a little bit extra. How many servers? Well, you've got to do capacity planning, and you've got to understand that more capacity is more uptime, and we'll talk about that later. But you know what servers you need, so now we've got to online the rack of servers. This rack of servers just arrived at your data center. You ordered them, you checked all the boxes in your purchasing checklist. Last slide, great job. You've got a proto cloud. So now what do we need to do to get it going? Well, we need a list of BMC MACs and logins that hopefully your vendor gave you. You need the server correctly cabled. You need the network configured, uplinked to the switch. You need even a network architecture has been done at this point. You need the power run to the rack, power run to each server. Hardware has to work the first time, which is a bigger problem than you might realize if you've not worked with commodity servers before, and that all hardware was delivered accurately, that you got all your RAM, all your cores, all your GPUs, everything that you expected. And only after all of this is in place can you start getting software involved at all. So how do you go from online to provision? And I'm using sort of ironic as an example here. Well, you had to create an ironic node. You might have done that manually. You might have had some sort of automated online script do that, or you might have even used Ironic's inspection functionality to onboard it. Your conductor has to have certain network access. Your agent image has to be valid for the hardware. The agent has to reach the API. The instance image has to be valid for the hardware. And I mention images twice because that's a super common failure mode. And the BMC has to actually work. You have to actually get the service you were sold, which again, you would be surprised at how many times in the real world that's not true. But here's the really hard part. It's got to do this every single time. Every time you're ordering hardware, you have to do this. Every time you're provisioning a machine, you have to go through that little Rube Goldberg machine before. If you're inspecting a server, provisioning a server, onlining new ports, and repeatability is a key part of this. But our users don't care. Nobody really cares about this. They want infrastructure, and it's our job as people who operate a cloud to give it to them. They just want to walk into that blank room and just say, give me lots of servers, and have just the racks go whooshing by like magic. And so, cloud's not just about APIs and servers. It's a service. In fact, I would say cloud isn't APIs and servers at all. It is all about the service, because if you're not providing value, then you're not doing it. And here's the really sneaky part that a lot of people don't think about. You're competing for that service. Even if you're the only group in your company or in your organization that's onlining servers today, you're still in competition, because you're not the only service in town. We have people bringing in shadow IT from remote clouds, or even, your executives might be looking at AWS, Azure, GCP, Rackspace, any one of the 300 public OpenStack clouds we talked about, and all of them have lots of people trying to tell your bosses why they should get the money instead of you. So, who are your competitors here? Well, you've got, those public cloud providers. You've got some other infrastructure teams internally. If you've worked at big companies or big universities, you know that there may be more than one game in town, and OpenStack is an option among many others that might include a legacy provisioning workflow, that might include VMware, or, I really do think about that little system that's in the corner for 30 years that has some sort of manual documented deployment process and everyone's scared to bring into the cloud. That has to be deployed some way, and I guarantee you someone else in your organization wants to use it tomorrow instead of OpenStack for some reason that you could never understand. But really, we're also competing with the fantasy that's told by the last technology salesperson your leader talked to. So this is, you're kind of fighting against fantastical claims even though you're living in the real world. And it's likely you're going to be measured against those fantastical claims even though you're in the real world anyway. So that means that our job is not just about technology. Our job is to show and to ensure that the cloud that you're running, which is probably a private internal cloud, is the right choice. So let's talk about what we have to do in order to provide that quality service. Well, I'm going to look at the public cloud, right? Because that public cloud, they've got some of these boxes checked. They have to check all the boxes. They have to be able to teach people about the value of their service. So we need to be on our A game, and I'm going to steal their playbook. So we can't really fight back against unrealistic claims, but there are lots of lessons to learn here. And so first, let's kind of talk about product management. In a public cloud, product management might be proactively researching new technologies or approaches that customers might want. They might be telling the customers about the new features that they can provide that they couldn't do last year. They're focusing investments into initiatives that they've determined have good value to effort ratios. They're not chasing fantasy ideas or dogmas. They're doing the things that are going to bring the most value to their customers and the most value to their business. And so how does that map to a private or an internal cloud? Well, I like to think of this as requirement negotiation, because your company is going to be asking you to deliver everything. They're going to be asking you to deliver things that may not even be possible in the real world you're living in. And so it's important to think about this explicitly. Document what the basic set of requirements are for a cloud, what the base level that you're not going to go belong is. Figure out how to prioritize that future work by engaging with the business, by finding out what do they need next. And you have to ensure that your budget matches the business requirements. I promise you, you would rather have the hard conversation with your bosses today about maybe making sure you're checking that box of having a standards compliant BMC, maybe making sure you've got that automated network set up. Because if those pieces are missing, you're not going to be able to meet those requirements. And there is an inherent exchange here, just like would happen in the public cloud, where you have to pay for quality if you want quality. So what about marketing and sales? Public clouds have entire teams and people dedicated to obtaining and retaining customers. And so we kind of have to look at how we can use internal communications as a tool in the same way to bring people more in line with the way that we see the cloud operating. So like on the public side, you might have them communicating with those customers over and over again, like we talked about. They engage them and show them the power of workflows that can be enabled through demos. We saw examples of that earlier today of people showing us the cool thing where you've got the little dancing videos sliding between clouds. That's great. That's an amazing capability. And also with the cloud service, they have a heavy focus on onboarding and migrations. They want you to be able to pick up, use their service, and get started. So we have a little bit of a difficult thing because by default, IT, especially internal IT, is sort of invisible when things are working, and we become visible when they're broken. So what this means is that when you're using internal comms to be your own marketing department for your team, you've got to think about telling your users about new features or maybe about workflows that they could use to make their life easier, training them in the right way to go. You can ensure that the successes that your team has are as visible as a failure. If you've got those multiple provisioning workflows in yours, and maybe one of them is file a ticket and 3 months later servers arrive, and the other one is call an API and get them, Well, maybe you accelerated a team to get something delivered before they would have even gotten hardware under a different product. You have to think about these and see them as the successes they are and make sure that you talk about them. Make sure that you're proud of them, their achievements. We sort of take for granted these days the magic of the cloud versus sort of this old way of thinking about things. And another one that's really big here is ensuring that the key performance indicators, the KPIs that you're being measured by, that your team is being measured by, is under the control of the cloud team. So this means, if servers are purchasing is delayed, then that shouldn't deem the cloud for not having the capacity. If you've got a hard drive that needs to be replaced, that's not a problem with the cloud software. That is, whoever replaces your hard drive needs to get hard drives replaced faster. So sort of think about these and make sure that you target the things that you're measuring your success on as a team for things that you have control over. And this references back to that requirement negotiation. This is why it's important to have conversations about expectations up front, because you want to be measured on something that you can actually achieve. So customer support is another big thing in public clouds, and this is an interesting one that I don't think a lot of people think about, because when you are dealing with support in a public cloud, this is often a private exchange. This is something where you're sending an email or filing a ticket, and you're in communication, and you maybe don't know how systematic a problem is. You don't know if you're the only person broken, if you did something wrong, or if maybe an entire shard of a service is down, or things of this nature. And so you don't get a good sense of the scope of the failure unless it's huge. And that is one of the big downsides of the public cloud, is if you have a failure of a large enough scope, it's going to cost years of credibility there. And they have lots of self-service support resources. The private cloud idea is user support. It's very similar, but you have to think about how it's different in an internal workflow. Your bosses are going to know when ticket volume goes up. You might even have a public channel where people are asking for help and where it may appear like more things are broken than it seems. And this is where it comes from, talking about those successes and making sure that people know that for every failure, for every ticket that comes in, you've had 1,000 successes. And that's not always obvious for people who aren't familiar with the real world, because we've kept them on the other side of that. The other thing is, and I think we've gotten a lot better about this as an industry in 2025, but IT used to have a very adversarial relationship with their users. And it's really important to make sure you're professional and you're polite, even if your users aren't being professional and polite, because in the same way that large scope failure can crater the reputation of a public cloud, one bad interaction with an influential user is going to cost your team a lot of progress and a lot of face in the eyes of your company. And part of that's also giving those resources to customers so that they can understand and prevent failure. The only reason your cloud exists is to serve those users, and that's important to remember. So with a public cloud, you might have an SLA, a service level agreement. That generally defines, exactly what you're paying for, how long you can expect it to stay up, and internally, we kind of map that again to expectation management. We write it down not just to having the conversation, but to documenting that conversation about it. You might have acceptable uses of the service. Well, on the private side, maybe that means that you have specific usage patterns. Maybe there are entry points that you're supposed to use and, not bypass some sort of internal process to get there. You have to have clear scope for what each team is responsible for. And we'll get into this with detail later, but let me tell you, you do not want to be asking who's responsible for performing backups after the backups are needed. So this is the sort of thing we're talking about, of making sure that the lines are clearly drawn between what value the cloud is providing and what value others are providing. You can document availability expectations. This is one that it took me well too long in my career to learn. As IT people, we kind of default to thinking of, we need these 24/7 uptime. We need to be able to provision servers at Saturday morning at 3 a.m., even though, maybe no one in your company is working then. And so that's actually a positive flip side of this. It's not just about getting things that you've got to deliver more. Maybe you can narrow that window to 9 to 5. Maybe you can have a long overnight maintenance window if you need a long overnight maintenance window. Again, the real value here is that you're tailoring whatever's necessary to what your business needs. You're not trying to take a cookie cutter approach, which can kind of be tough to see when literally we're providing a facade, right? We're providing a service. So, and the other thing is that public clouds have a big leg up on us for billing and for pricing, because there is a direct relationship between how much your company is paying and what they're getting back. And that's something that can be really muddled if you're working internally. And when you're dealing with that, it has to be accurate. It has to be audited, it has to be correct. You have to dot your I's, you have to cross your T's. And the other thing you can do with pricing from a public cloud perspective is reflect how much it actually costs you to keep a service running. So if you have an older service you're trying to offline, maybe that gets more expensive from a public cloud perspective, but you may not have that option internally. So internally, the way this is handled in companies are very different, and so I don't want to necessarily assume how it is in your organization, but the key point here is to create a relationship between the value that your team is providing and the effective cost to the company, because you want to be able to show how that relationship works. But the nice thing here is accuracy is less important here. You're not going to be charging people bills for what they're doing. You're just trying to get an idea, a sense of what the value that's being brought. And the other important thing about this is that you really do have to have this concept of who's using your hardware, how much value are they bringing to the company, so that your management can decide, you know, you've got 10 servers, you've got people who want 12, who comes up too short. But you know, we've talked about this, but public clouds don't necessarily hold the upper hand. Internal clouds have huge advantages, and these are really important to understand if you're running one, so that you can take advantage of them, so that you can, you know, sort of take your home field advantage. One of those advantages is knowing the business, because public clouds have to service a common denominator among companies, but that's not true for your internal cloud. You can do things like capacity management. You can take maybe that unused hardware that's sitting in racks unused because some project got canceled or is delayed, and see what can your company use that for. Maybe there's someone who can use that to be extra QA resources. Maybe you can utilize that for some other project that's been neglected or under-resourced. But you can think about these things and make sure that your hardware is being utilized to the fullest. You can know that your business has like a slider, it can slide here between capacity, headroom, flexibility, and consistency for users. The less flexibility you have in how instances are scheduled, and the less capacity headroom you get, the more errors your users will see. Because a large portion of OpenStack's high availability as far as presenting you resources is that it can retry, and that means that you have to have resources available to retry into. That's not saying that you're wrong if you don't have any slack capacity, but it's important to make an explicit choice between the flexibility, how much capacity you have extra, and how much your users have toleration for getting errors back from the API. And the other one, and this is upgrade hardware on the business's timeline, and this cuts both ways. If you've got servers that are working fine, you don't have to migrate off of them. They're inside your data center. You can leave them there. You can keep using them for as long as you want, as long as they're security supported. But the flip side's also true. You know, if you know the power coming out of your data center, and you know that more efficient servers are coming, you can circumvent that upgrade cycle. Do it more quickly. This is some of the power you have using capacity management for this way. The other one is managed services. And this may seem weird to be about knowing the business, but we all operate on kind of different levels of technology company, right? So, you know, I work at a place where we have a platform, and then there are other teams that have their own technologists that are interacting with that platform. So we are in a position closer to a public cloud than a private cloud in that sort of environment. But maybe you're a place where you're the one-stop IT shop, and that might mean that you need to take on more scope and you need to provide more management. Managed services like maybe deploying an object storage and giving it to your customers, maybe deploying a way to easily provision databases or Kubernetes onto those machines. Those are things that you might need to think about if they provide value to your organization. The other thing is, you know, you can talk about more scope to provide more value, but it's important that these things be documented. In fact, this is the reason I mentioned it the second time, because this is very common failure mode for this. Who's in charge of backups? Who's in charge of monitoring? Who's in charge of security patching your OS or your firmware? These things are important to know who's responsible for. If you're responsible for it, then great. You can make sure a good job is done. If your users are responsible for it, that needs to be documented so someone isn't knocking on your door asking why you were breached by a firmware issue that was fixed 6 months ago. And the other cool thing with knowing your business is advanced troubleshooting. And we've kind of talked in generalities and scoping your work. But some of this is about the Scotty factor, right? I'm not saying you should do less. I'm saying you should promise what you know you can achieve so that you can then go above and beyond that. That may mean that one of your users are experiencing weird performance characteristics. Well, you own the entire stack. You can go all the way down to the hardware and troubleshoot that. Isolate it for benchmarking. Was a driver or firmware update potentially to blame for some sort of performance? Well, you control all the moving parts. Roll it back, see if it's better. Talk to your vendor directly rather than trying to escalate your way through a support chain. Did your hardware fail or is it inadequate? Well, it's maybe recoverable. Maybe you can go take that disk out of your server, out of your physical server, and go take it to a data recovery facility. Maybe you can put more RAM in that server instead of having to completely tear it down, reinstall it, and replace it. So another advantage is that you control your data, and we've talked a lot about data sovereignty already today. I'm going to assume y'all were here for the keynote, so I'm going to gloss over a lot of this. Security. You don't have any risk of cross-tenant data leakage if there's one tenant, and you're an organization that can rely on that. You can ensure the data is used for your business and not to train someone's AI or not to go into some other thing that you might not want. And another big thing is that you reduce your external account service. Your external attack surface. You can control your data by having it locality. You can avoid the lock-in that data gravity causes. And if you're not familiar with that, is simply the fact that where your data is your status quo. They're going to have a huge, huge advantage over other things because you're going to have to get your data out if you want to change. And so holding on to your own data, being your own kind of source of that data gravity can be important. Data sovereignty and compliance, crossing fewer political borders. Maybe you can keep your data in the jurisdiction you want your data, and you can have more direct control over DR and backups. I know a lot of people whose DR plan consists of, if this public cloud region goes down, I spin everything up in the next region. And I can tell you in practice, you don't want to be calling those APIs at the same time everyone else who uses Amazon US East 1 is calling those APIs. You're not going to have a good time. And another advantage, optimization. You can tailor your environment and your hardware. You can get hardware that isn't sold in a public cloud. You can get an AI accelerator or a GPU to run those AI models. You can control your network latency. You can use some industry-specific or specialized hardware. There was some talk up here earlier about telecoms running OpenStack. I bet that has a big part to do with why telecoms are using OpenStack, because I bet they have some crazy hardware that I would love to see one day. Or maintenance windows that fit in your business or time zone like we talked about before. Optimization in terms of business integrations. You can use existing automation that your company might already have and integrate it into the cloud, integrate the cloud into it. Hook up notifications from your OpenStack services into your automatic failure resolution system. Automatically update your internal systems like inventory or finance so that maybe that's the hook you need to enable that chargeback we were talking about earlier with billing. But what can you do today? We've talked a lot about big ideas, but let's talk about actions that you could go take home and do right now. You can represent your users. You can meet with your users. You can find their pain points. You can propose plans to management to reduce those pain points. Maybe that plan comes with a dollar amount. That's perfectly fine, but you want your management to make those decisions, not you. So that you document the outcome of that, and then it's up to the business to deal with the consequences and not necessarily your team, because you've already documented those expectations well. You've got to represent yourself by documenting the scope of the cloud team. And this kind of gets back to the system paradox I was talking about earlier, where no one notices IT when things work, but they notice when it's broken. And so this means you should be talking positively about things your team is doing. Talk about a success rate rather than a failure rate. Measure how many servers were provisioned alongside the number of servers that might have failed provisioning. Be loud when your cloud does good things. And finally, partnership with your business or with your organization. If you don't know what your company's doing in the next 2 or 3 years, how are you going to be able to provide cloud services to that? That's a conversation you need to be a part of. What's next and knowing what's next. You've got to ensure that your leaders understand that relationship between budgets and the trade-offs they're making. Make sure that the usage matches up with the value that those are provided, that you don't have a noisy user who's not providing a lot of value to the company. And monitor and correct perceptions about the cloud. You need to know the answer to the question, what does your C-suite think? Does your C-suite think your cloud team's doing a good job? And if you don't know the answer to that today, you should find out. So some quick conclusions. If you leave this and you only remember these things, Running a cloud involves much more than OpenStack. It involves much more than software. Providing that value to your business is more important than following a specific technological dogma. That means, maybe you've got to run software that's not OpenStack, if that's what your company needs. That's what you've got to do. It's about providing the value, not about how you provide it. You can tailor your cloud to meet the business needs, and then again, you can take it from, Scotty from Star Trek, document your team's scope, set a minimum expectation, and then go above and beyond every single chance you can. And keep your users in the matrix, because the real world, very cruel. I'm not sure we're going to have too much time for questions, but please do check out the podcast. I actually just posted a short this morning of my next guests, Jeremy Stanley and Clark Boylan. That's coming up this week. Search your podcast app of choice for GR-OSS, or click the QR code or have a conversation with me if you want to work with or on open source software in Dallas or London. Thank you all very much for your time.
coming here today. My name is Jamie Parker. I am a product manager for observability at Red Hat. I cover both OpenStack and OpenShift, which is our Kubernetes. Sorry, I forgot there was a microphone. So apologies for that. My name is Jamie Parker. I'm an observability product manager at Red Hat. I cover both OpenStack and also OpenShift at Red Hat. And so I'm here and I'm happy to talk to you today about observability for OpenStack on Kubernetes, which is very cool. Yes. How about this? Is this better? Hey, all right, success. Okay. So traditionally, observability in OpenStack, you have a handful of services that we've used. You have SysLometer to gather telemetry from the different services. You have syslog that can collect and transmit logs, and OS Profiler that can be used for traces. So this is a pretty traditional, pretty standard observability stack within OpenStack. But now we're seeing more and more organizations and enterprises move to OpenStack on Kubernetes. Why are we seeing that? The Rackspace keynote gave really good information on that. You have a lot of resource sharing that you can do. So you can share resources between Kubernetes, between OpenStack. So that's very useful to have that resource and hardware sharing and also operator sharing. You have a lot of deep understanding of Kubernetes administration at this point from a lot of system administrators. It makes sense to pool those resources and have those resources combined. So this is really useful. We're seeing a lot of resurgence of OpenStack on top of OpenShift. And it's a very nice combination. But, oh, the complexity. Oh no, you've got services on top of services, you've got networks on top of networks, you have pods, you have containers, you have all kinds of things running around. How are we going to observe this thing? How are we going to make sure that this thing is up and running, it's healthy, it's doing what we need it to do for our users every day? We have an entire OpenStack environment to observe. That doesn't go away. We have an entire Kubernetes environment to observe. That's not going away. And then we have to observe how they're interacting together. So how are we going to do this? So you have a handful of observability tools. We see the OpenStack ones. We're familiar with those. There's also a handful of CNCF Kubernetes observability tools. What are we going to use? Well, just like we talked about a few minutes ago, let's combine these resources. Let's use both. So our ultimate goal here is end-to-end observability. We need to understand everything that originates all the way from OpenStack, all the way down to into Kubernetes, and then even on the hardware level. We want to know everything because any one of those things could be affecting our performance. So we have the 3 pillars of observability that we can utilize here. We have metrics. So metrics are very good at telling you that there is an issue. We have logs. Logs are extremely good at telling you what is the issue. And then we have traces. Traces are not utilized, I think, to the extent that they should be. I'm going to talk more about that in a minute. Traces are very good at telling you exactly where the issue lies. So our goal here is how are we going to use these 3 things to get our full end-to-end story of OpenStack on Kubernetes and getting it running nicely and reliably. So let's start with metrics. We use SysLometer, of course, now in OpenStack. SysLometer is very good. SysLometer integrates with OpenStack services. You can use SysLometer agent for your compute nodes. You can use SysLometer in many different ways. There's no need for us to stop using SysLometer. We're just going to combine it. So we're going to combine SysLometer with Prometheus. We're going to use the SysLometer Prometheus exporter, and we're going to use Prometheus to collect our metrics from both OpenStack and Kubernetes. You have all of your metrics there, so you have a deep understanding of your entire system that's running, both OpenStack and Kubernetes together. We can also, if this is a newer environment, so we're new to this, we might want to consider OpenTelemetry. OpenTelemetry is very useful in lots of ways. I'm going to go into this more in a minute. So OpenTelemetry has a SysLometer receiver. You can send your SysLometer metrics directly into OpenTelemetry. OpenTelemetry has a lot of transform filters, a lot of export options. One of the big things today has been data sovereignty. OpenTelemetry has native PII filtering and lots of other things that you can do with your telemetry data before it goes off cluster. The one thing about OpenTelemetry is that you do have to bring your own storage, but we're going to talk a lot about that in just a few minutes. So these are some things that you might want to consider if you need to balance your OpenStack and Kubernetes metrics. All right, so now let's talk about logs. Logs are one of the most critical pieces of observability signals that there are. syslog, already supported in OpenStack. Syslog is great. It is a standard protocol and understood by many analytics engines, and you can use it to export the logs off of the services, export the logs off the compute nodes, so no change there. We are already familiar with syslog. What are some other tools that we can use to combine that? Vector is a very good Kubernetes-based log routing system. Vector can receive logs, can collect logs, and forward those logs. Vector has agents. You can choose to run those on your compute nodes, or you can go ahead and export those via syslog into Vector. Vector is Rust-based, very fast, very scalable. So you can use it to pick things up off of Kubernetes and OpenStack at the same time. Very good, very strong. So Vector is one that we actually use at Red Hat, so I'm pretty familiar with this one, would highly recommend it. You also have the OpenTelemetry collector here too. So OpenTelemetry can collect metrics and logs and traces. Very powerful. So if this is a new system you're building, OpenTelemetry is absolutely something that you should consider. OpenTelemetry has an rsyslog receiver, so just like Vector, it can receive those metrics off of the compute nodes, off of the services. It can do those same filtering options, those same transformation options. You need to send them off cluster, you want to filter for PII first, you can do that. So OpenTelemetry Collector is absolutely something, another one that you should consider here. And then now let's talk more about tracing. Again, like I said in the beginning, tracing is not something that I think is utilized enough. So tracing, think of them as super logs. Traces consist of a span. So the span has information about all of the places that it has been. The span can tell you what services it's touched. The span can tell you how long that it has spent in those services. If you're running a system as complex as OpenStack on Kubernetes, tracing is going to be your best friend, because the tracing can go all the way from the compute node, even the application that's running on it, all the way down to the hardware level, get collected, and show you immediately where the bottleneck might lie within your system. If you combine the traces with the logs and the metrics, then you can very, very quickly reduce a lot of the complexity that you're going to see with these systems, distributed systems. So again, traces, super logs with context and timings. So in a big system, your best friend. So what can we use for tracing? OS Profiler, I mentioned it. So this has been historically the tracing for OpenStack. It already supports the OpenTelemetry SDK and OpenTelemetry exporters, so you can be set with OpenTelemetry there. If you're building a new system, again, you may want to consider that. OpenTelemetry was actually built for traces. This is the second largest CNCF project behind Kubernetes. OpenTelemetry has very, very strong tracing support. OpenTelemetry is also going to be a thing that you can use for more than that. Again, filtering, transformations, you need different things to look different ways because you want to export them to different systems. And OpenTelemetry can do all of that for you. So that's going to be a huge tool in combination with OS Profiler. So very good for you to use. And then also mentioning Jaeger. Jaeger is another very popular CNCF project. Again, Jaeger is Zipkin based, so not quite as useful. Zip can be a struggle on OpenStack. But the combination of OS Profiler and OpenTelemetry is going to give you a very, very strong base for your traces. But what about my applications? Well, the good news is that all of these products that I've mentioned already have ways to collect the metrics, the logs, and the traces emitted by your applications. One more thing about OpenTelemetry, it has auto-instrumentation libraries. So OpenTelemetry has a means to inject instrumentation into your applications as long as they are .NET, Java, Node, Python, or Go based, which many of them are. So if you have a legacy stack, you're struggling with getting some metrics out of it, you're struggling with getting that instrumented, you can use the libraries from OpenTelemetry and the OpenTelemetry metrics auto injection, and you can get some preliminary observability out of your applications. So this is an excellent way to go if you don't have metrics for your applications already. You got to put the stuff somewhere. So we got to store it. So we have a lot of stores that can be utilized in both Kubernetes and OpenStack. So you have your metric store, Prometheus, I mentioned earlier. Prometheus is also a metric store. OpenStack is a little bit unique in that OpenStack has a hard tenancy model. There is a newer product from Grafana that's open source called Mimir. Mimir gives the tenancy model to your metrics. So if you have something where you're running a tenant environment that has a hard tenancy model for your customers or for your users, you may want to consider Mimir for tenant storage because it'll just be easier to pull those multi-tenant metrics out of Mimir. For logs, Loki is a very fast, very scalable S3-based log storage tool. Very quick, very easy to search, highly recommended. OpenSearch is another good option. So this is a fork of, kind of a fork. This was a diversion from Elastic. So if you're used to Elastic in your environment, you may want to consider OpenSearch. Again, another very powerful log storage tool, very good at searching as well. And then for traces, Tempo, very similar to Loki, also has strong storage for tracing, and then OpenSearch can store traces as well. So good recommendations for storage because you need to store all of these observability signals so that you can do analysis, you can understand what's happening, do the research into what might be causing your bottlenecks and your issues. And very last thing, so we've got it stored, we've got it collected, now how do we look at it? There's two really great tools for looking at this observability data. Grafana is classic. Grafana, the open source version, is very powerful, supports visualizations for many storage options. All of the ones that I listed before, you can visualize from there. Another one that we have been working with at Red Hat is called Persis. This dashboard that you see is actually from our Persis implementation. Very similar to Grafana, you can visualize from your storage options. There's two things that we really appreciate about Persis and why we would recommend it. It's embeddable. So if you have a website that you're working with and you need to embed a dashboard into that, you can do that quite well with Persis. It also provides dashboard as code options. So if you are going into your OpenStack deployment on Kubernetes and you're wanting to have CI/CD pipelines, you're wanting to do infrastructure as code, you can define your dashboards as code as well. You could define a standard series of dashboards, send them to your users will know that they will be there. Very quick, very easy. Persis is a very powerful open source tool. So again, we recommend it. All right. So with all of these tools together, we've combined our OpenStack tools. We can observe our OpenStack environment. We understand what's happening there because we've got our metrics, we've got our logs, we've got our traces. We've also got our Kubernetes environment. We have metrics, we have logs, we have traces there. So we can understand the health of our OpenStack environment. We can understand the health of our Kubernetes environment. And we got some bonus management tools. So we have bonus management through alerts. Prometheus is very good at alerting. Some of these other tools provide alerting as well. We have storage, so we can keep our signals, we can analyze them, compare them. And we have visualizations, so put it all together. So success, big success. We've achieved end-to-end observability. Fantastic. But wait, there's more. Some other observability tools that are really going to be quite useful. You have all of these things. How do you analyze them? How do you get to this mean time to resolution even more quickly? You can use an open source project called Correlator. So Correlator is an observability tool. It will correlate these observability signals for you in a Kubernetes cluster. So if you've got your metrics, your logs, and traces from OpenStack stored, then you can also use Correlator to correlate these tools. So it can correlate metrics, logs, traces, and net flows, which I'll talk more about in a second. So this will give you a faster way to resolve the issues in, again, a very complex environment, just even more, making your end-to-end observability even stronger. NetObserve. This is a really powerful tool for understanding network flows. So these are the network flows that Correlator can also work with. This is eBPF based. It generates the network flows from the packets that go through it. And it can make those available through Prometheus metrics, through Loki. It can store all of these net flows in Loki as well, and then export them to a collector. It can also export to OpenTelemetry. So this is, if you're needing help with your network environment, which again, we have OVN on SDN on all the things down to the hardware layer, network observability is a good option. eBPF in general. There are more and more tools coming out that are eBPF based. It's very lightweight, very powerful. It gives you some very strong observability capabilities and works really well in a disconnected environment because it can communicate with the Linux kernel directly. So there are some pretty useful tools that I wanted to list here. BPF will manage all of your BPF deployments. Coretta is a way to map Kubernetes dependencies if you have a need for that. That's eBPF based. Network observability, of course, and then Kepler for monitoring your power utilization. Speaking of Kepler. So Kepler is a Kubernetes-based power level exporter. This uses eBPF to get CPU performance. This works, since it's eBPF based, it works equally well in Linux, and it will work in OpenStack. So this is a way that you can monitor the power utilization of your OpenStack nodes. So very useful, and then export the data to models so that you can analyze and get an idea of how to reduce that power consumption. So I included some resources here. I think that they're going to make these slides available. So when they make these slides available, everything that I've talked about is linked here. So you can get links to all of these. Some of these you'll be familiar with, Ceilometer, OS Profiler. And then some of these maybe not quite as familiar with. So this is links to all of the open source documentation and downloads for you so that you can explore these and figure out which ones work best in your environment. And thank you. I appreciate the time. And I don't know, do we have a question second? Okay, I think there's questions. Yes?
You mentioned the strong tendency of behavior. Is there something similar for logs?
So Loki has a tenancy model as well. And you can also extend the Loki tenancy model. So yes, Loki. Other questions? Okay, well, in that case, thank you very much. I appreciate it.
Yeah, exactly. Oh, sorry.
Is this going to work?
This don't go?
Ten setup to jest dosyć ciekawy, nie?
Co weźmiemy ten mikrofon chyba do ręki, co? Bo ten nie działa chyba.
Nie działa? No to spoko. Weźmiemy do ręki. Nawet nie zauważyłem, że mamy logo firmy na dole.
Gdzie?
No w sensie na tym slajdzie.
Męczyłem się z tym z 15 minut, żeby dodać.
I don't think so. Don't worry, it's going to be fast.
Well, actually, it's a bit overselling, to be honest. Zostawiasz mnie? Hello, everybody. My name is Bartosz. I'm working at Stack HPC as a cloud engineer. I'm also a OpenStack core reviewer, and we have also Michał.
Yeah, hello, my name is Michał Nasiatka. You can call me Michael if that's easier. Yeah, so I'm a senior technical lead at Stack HPC, long-time Cola core reviewer and project team lead for like, I don't know, 6 or 8 cycles. Yeah, so let's go.
Let's start a bit about our company. It's almost 10 years old, Stack HPC. We are based in Bristol, United Kingdom. Most of the people are there, except a couple of locations in France and Poland, where we are from. And we are, as the naming says, founded on high-performance computing expertise, focusing on delivering that to customers with SDN, software-defined networking, and mostly around research institutes, like universities, but not only. So we are addressing that with our open source heart, I would say. We are a OpenInfra silver member, and by recent metrics across several releases, we are second or third, depends on of the release. By personal day effort metrics, contributor to OpenStack. Therefore, I think that's somehow significant for that small company, I would say. We have also other open source projects, like Azimuth, for example, and everything is open source, even documentation. Okay, today we are going to talk about OVN in OpenStack and some challenges around that. Let's start from reminding ourselves how does it work from the internal point of view. So we've got our cloud, I hope that's visible somehow. This lovely schematic, which I adore, is from OVN documentation, but I very like that. So we have on the top cloud managed service, in our case is Neutron, and its OVN driver. It can be different, like I think somebody mentioned kubeOVN, for instance. So it's our networking configuration in OpenStack being translated to node-bound database, OVN node-bound database by a CMS, by the driver, in case ML2 OVN. In node-bound database, we are storing logical network configuration, router, network subnets, that we all know from OpenStack. Then it's being translated into lower level flows by Node-D component to the southbound database. Node-D is like I mentioned, translating that from high level desired state configuration into low level flows in southbound database. In this case, a southbound database is, in my opinion at least, heart of that, where every hypervisor is connecting to. A small remark, it can be a different way, it can be done by southbound relay as well, which is a recent improvement in that, especially in big scale if you have like over several hundred hypervisors, then you would need that relay for sure. So Soundbound database is comprised of those flows and physical binding for each hypervisor. Then OVN controller component. By the way, northbound and southbound databases are clustered components utilizing Raft algorithm. So it's highly reliable. I haven't seen a crash, to be honest, on that front, at least yet. So we are on the OVN controller, which communicates with southbound databases or relays and translating flows from southbound database to actual open flow flows to configure OVS instances running on each hypervisor. So in our case, Neutron 8 CMS communicates with northbound database, and like I mentioned, the ML2 OVN driver in Neutron communicates with northbound database. External ports are somewhat which interest us the most in this presentation, because they are a representation within the OVN for external entities like bare metals, needs which are needed for OpenStack Ironic project here, and SRIOV network interfaces of virtual machines. So those external ports are logical ports within the OVN, and they are providing OVN services which are needed for those hosts, like DHCP, DNS, and also IPv6 router advertisements. In OVN, we are configuring those external ports on northbound database like every other logical component. Important to notice is those ports are being managed by HA chassis groups between the chassis, which is in OVN nomenclature, the dimension of the hosts that will be configured. That's a network node, that is. And this will be important in the issues part of this presentation, or rather challenge, I would say. HA chassis group is important. It needs to be connecting outside, of course. So L2 connectivity is needed, and in the OVN configuration is a local net port, which basically means a VLAN. Okay. Very good. So I tried to replicate a bit the OVN documentation in terms of styling, at least. Sorry. No, that's not good. That's not good. Okay. Anyway, so I would like to go through the logical flow of this setup. How from the OVN perspective, how it should be configured. Is it visible? Probably. So on the top we have our bare metal or SRIOV NIC virtual machine. It's obviously connected to the physical network directly. Then we have HA chassis group on our network nodes, which is in highly available communication between those several network nodes, for example. And then we have local net port, which is a VLAN, like we mentioned before, connected as within the logical switch and logical switch port type external. And that's important because it's actually associated with a HA chassis group. And then we are going to the northbound database, and which is then serving our OVN services that we would like to have. Like mentioned, this is important bit. I would like to be mentioned as well that this is, for example, SRIV, well, the primer like I mentioned before, but it's enabling high performances to bypassing the kernel network stack, and our bare metal ports managed by SONiC. And important bit is that Neutron external ports are special types. So to be able to utilize that, you need to specify the VNIC type within the Neutron configuration. Right, and this is also important that it don't need to be configured directly in OVS, of course, like all setup of OVN. Okay.
Okay, my turn. Yeah, so basically, Neutron has a mechanism that schedules external ports onto gateway chassis. So there are different scheduler plugins that can be used. The default is the least loaded scheduler, which will do a priority list of your all network nodes at maximum 5, I think. And it takes the least loaded gateways in the front of that list, which ensures efficient scheduling in terms of load distribution. Then we also have the HA chassis group that was mentioned in previous slides. So it's a concept introduced in 2019 to manage multiple HA chassis for those services that the external port needs, like DHCP and others, and DNS, for example. And it ensures that the external ports are bound to the master chassis based on priority. So, yes. And of course, if master chassis handles the port and it fails, then the backup will serve those additional services like DHCP and DNS. Yeah, so challenges. So external ports and router gateway ports may be bound to different chassis. So you end up with having DHCP and DNS. Well, DNS not really working because OVN will forward the DNS query to some upstream DNS server, and if there's no router on the same chassis, it's not going to do it, right? Yeah, so basically if you have different priorities on the HA chassis group and different priorities on the logical router port of your router, you end up with lack of routing. Yeah. So there's also another problem, but it has been already handled by Neutron since Yoga. So in the past, there was like one HA chassis group, which caused MAC address issues. But now we have one HA chassis group per logical switch, which ensures no MAC flapping between physical switches, which they don't really like. Yes, so currently redundancy is managed separately by Neutron for gateway ports and external ports. And it leads to lack of routing, right? Yeah, so there's a history behind it. So initially there was an option in logical router port entity that was called redirect chassis, and that was the only option. It was then deprecated when gateway chassis table was introduced. And then in 2019, OVN developers introduced HA chassis group for handling external ports. Yes, so we had 3 different options that could be like defined for routing, because if you have, if your logical router port does not have gateway chassis entries, OVN will use HA chassis group for routing, right? Yeah, and in version 2012, so it was December 2020, redirect chassis has been removed and docs have been updated with some recommendations how to use gateway chassis and or HA chassis group. So basically, if you set only HA chassis group, routing will work, but Neutron currently is setting both gateway chassis and HA chassis group with different priorities. Yes, so possible solution that we're working on. So aligns shadowing strategies for both external and router gateway ports, so these are consistent. And use HA chassis groups consistently across all port types, but sort of. So initially there was a plan of a new scheduler for OVN that will align gateway chassis and HA chassis group priorities, but since the latter can be used instead of setting the former, so we only set HA chassis group and we don't need to set gateway chassis, it's a matter of rewriting the logic. But there's a feature in Neutron that is called enable chassis as export host, where you can choose that the HA chassis are different than the gateway chassis. It seems that there are use cases for it, which I don't know which ones, but there are, right? Yes. So basically, yes, we're rewriting the logic to take into consideration if enable chassis as export hosts are enabled in your environment, then we will do what Neutron is doing today. And if not, we would just set only HA chassis group, and then the L3 routing will work properly. Yeah. And that's it.
Do you want a microphone?
Document as in, you're asking if it only needs documenting how it works today? So basically, those can be scheduled separately today, but you won't have the L3 routing capability for your bare metals, for example, right? Yeah, with introducing the enable chassis as export host, there's some part of documentation in Neutron which says that it's like a useful for some use cases, right? Which I don't know which are those use cases. It would be good to document them. Yes, but basically, I don't think it's expected for most people to boot a bare metal and they get the HCP, but they don't get L3 routing outside of their network, right? Yeah.
I think the export host feature was also for some totally separated environments
Yes.
with different communication needs or setup, and or without the routing, yes. Thank you. Anybody? Question?
So just so everyone knows, it's lunchtime. Enjoy lunch.
Hello, everyone. That was loud. Okay. Hope everyone had a good long lunch and that you're ready for the rest of the sessions for today. We are kicking off this afternoon session with a team from Red Hat, and they are presenting an overview of integration strategies between CephFS and OpenStack Manila. Please welcome Gautam Pacharavi and Carlos Eduardo da Silva.
Thank you very much for joining us today. So my name is Carlos Eduardo da Silva. Thanks for the introduction. I'm joined by Gautam Pacharavi. This presentation was also prepared by other colleagues like Ashley Rodriguez. So you'll see a bit more of Ashley tomorrow in the workshop that we will be doing, like the From Zero to Code workshop, where we'll try to get every single attendee to make their first open source contribution. So please join us on that. And the three of us are maintainers on the for the OpenStack Manila project. We work at Red Hat, and our work is like done mostly on the upstream Manila side of things. So we'd like to chat with you about something that's widely used but kind of misunderstood, and we are talking about CephFS in your OpenStack clouds. So this is not going to be kind of like a very in-depth talk about, like the internals of CephFS. It's more like a one-on-one talk where we'll discuss pretty much how things work, and yeah, you can figure out if it fits your use case, and yeah, including how to set up and how to use it, and how can you integrate with it. So this is our agenda for today. Yeah, first we'll talk about OpenStack Manila and how it integrates with CephFS, and then do a bit of a comparison between native CephFS and CephFS NFS. Now, we have a demonstration and the future plans that we have for the CephFS native and NFS drivers in Manila. So first, Manila, right? So as you might know or might not know, Manila can offer you pretty much self-service POSIX compliant shared file systems. They are kind of elastic and secure by nature, right? By design. So why is elastic? Well, you can grow them and shrink them as long as your quota allows you to do that in the cloud. And they are secure because you can also control the access to it with access control with ACLs, pretty much. So you can control who can read, who can write, and who can mount, pretty much. So in addition, Manila also provides different levels of multi-tenancy. So the cloud administrators can control the storage used through share types. So you can target or define share types with specific capabilities that will allow the shares to be scheduled to specific storage, matching those characteristics. You can define quotas, and you can also control resource visibility for a couple of resources like ACLs if you don't want to leak, or if you don't want to make available CephX user, for example, you can add visibility locks for that. It's a kind of a recent feature, but you can do that with it as well. So it's pretty much, it allows you also to reinforce access control lists. There is a more complicated design or a more complicated approach that you can take with Manila, which is pretty much allowing you to have more isolation over, like the networking, and having with the multi-tenancy isolation, we mean having multiple share networks and then granting the network isolation between the shares and the share servers. But we won't get into that today. So with Manila, you can create multiple shares of multiple NAS protocols like NFS, CIFS, SFFS, and others. And apart from that, you can also have a lot of other day 2 features for maintenance, like migration, replication, snapshotting, all of that. So next, CephFS, right? So CephFS, also open source, which is kind of like an awesome solution for you, because CephFS consolidates block, object, and file storage within the same cluster. So you don't need different storage for that. You can offer the 3 of them. And it simplifies a lot the management of the infrastructure, and it's easier kind of to maintain the cloud. It's also scalable, right? If you need more data, if you need more space, you can start adding more disks to it, and it will let you take an approach where you are not locked into a single vendor for hardware. So that's also another very important capability or important thing about CephFS. And at the same time, it's like elastic. It has a very mature quota management system. So yeah, another very nice thing is like crush algorithm, which will distribute your data evenly across the nodes, and there will be awesome balanced load distribution between the clusters, and you can expand them to like exabyte scale. So pretty cool, and I mean all of that with also something being like fault tolerant and self-healing. And as I said, open source, you can also contribute to it. You can help, like people take the decisions. So that's awesome, right? So a bit of the timeline of like CephFS and OpenStack Manila. So Manila was production ready in the Kilo release. But CephFS driver was implemented only on the Liberty release. And then we had the CephFS driver only supporting for shares only with the native CephFS protocol. And then the support for CephFS NFS came later, but we'll get to that soon. So back when we added it, what was, or even today, what is a share or a shared file system in the Ceph storage? Well, it is a subvolume within a file system. So it has a quota. You can define a quota, and the quota would be like the size that it would be allowed to grow to. And back to Liberty, it only supported CephFS native shares. In OpenStack Pike, it was introduced the support of NFS shares through NFS Ganesha. And it started, back then we would only support shares for NFS version 4.1 or newer. Next, we had Queens, right? When we had NFS Ganesha high availability added. And then we started, like making incremental additions to the driver. So next thing was like the next big milestone was multi-FS support. So what do we mean with multi-FS support? It means that you can have one cluster that has multiple file systems, and each file system will be represented to Manila as one backend, and then you can create shares in those multiple file systems. And then Yoga, right? We added Ceph, or the Ceph Manager API was replaced by the Ceph Volume Client, and Zed, one of the most recent, or one of the recent additions that we did, and it was like a huge milestone for us as well. You can see more details about that in other talks that we did, one of them at the OpenInfra Summit in Vancouver 2 years ago, but pretty much adding support for high available CephFS NFS services deployed by Ceph ADM, and that unlocks like a whole lot of new things for us. It also comes with like the AJA proxy protocol, and later then in the Envelope release, we kind of managed to also introduce support for helping you to migrate your cluster. So if you have a standalone NFS Ganesha, then, and you are planning to migrate, then you would pretty much be able to migrate, and you can have a period of time where you are transitioning. So you have the standalone Ganesha in the cloud, and then you are moving to the Ceph ADM NFS Ganesha, and then you can just have the two configured to Manila, and then we'll try to represent everything that you should be using. So we'll say, for example, we have like multiple mount pads. One of them is being exported by the standalone NFS Ganesha, and the other one is being exported by the Ceph ADM managed Ganesha service. So, and then we would mark the one that's preferred, which is the one that has the high availability capabilities as the preferred export location, so that people start mounting through that. And yeah, I think that covers a bit of the timeline. So in summary, what is a share in the CephFS or in the Ceph storage? It is a subvolume, and it provisions like subvolumes within a single CephFS file system. And Manila access rules, they will allow the subvolumes to be mounted, and you can configure the access rules. You know, like for NFS, you have IP and IPs or subnet. And for CephFS native, you have, you know, like you can deal with the users in the cluster. So CephFS volumes, they can be consumed via CephFuse or kernel CephFS and NFS v3 and v4.1. Support for NFS v3 is going to be a thing in the next Ganesha release, right? Yeah, it is a thing in the most recent and greatest Ganesha release. So yeah, that is available as well. NFS v3 is kind of like a use case where it's mostly targeted for people that are have Windows workloads. So yeah, now heading to Gautam to cover a couple of other things.
Awesome, thanks Carlos. All right, let's dive a little bit into the native CephFS use case. This was what the first integration with Manila was. And a bulk of the users back then, and even now, I think the largest deployments of CephFS anywhere, they're using native CephFS. What is native CephFS? Well, as with any, accessing any kind of storage over a network, you have a bunch of work that's being done at the server and a bunch of work that's being done at the client. And in native CephFS, the work that's done on the client is quite important. So there's a lot of enforcement of things like quotas that are actually done at the client level. So you can imagine if you have a distributed file system that's being offered on a cloud, you better trust all of your users and the clients that they're installing, because some of that enforcement could actually be wonky and mess up something on the shared infrastructure. And so that's one of the biggest differences between using native CephFS and gatewaying it with something like NFS, which is becoming increasingly popular, which is such a weird thing to say. NFS is becoming increasingly popular, but in terms of using it in a large multi-tenant cloud that OpenStack clouds typically tend to be, it is a popular use case there. With native CephFS, besides having this trust model, there's also the aspect of extending the Ceph network to your clients. So if you have the Ceph public network, that has to be accessible to your end users. So that could be their user VMs, and so they could directly connect to it, or they could route to it. Except in case of routing, you had to be sure that nothing in the network path is actually going to hinder the performance and so on. But you could typically just put them behind a router as well. And you would be using CephX usernames. And the word of warning here would be CephX usernames that are created by OpenStack Manila are globally unique, which means that a lot of people trip up with this. So you could create a CephX username assuming that, hey, I have a OpenStack user called J. I'm going to create a CephX username called J, except that's now going to be a reserved user on your Ceph cluster. So there better not be another J in a different project, which is not really congruent with the way OpenStack works, really. You should be able to assign users to different projects and so on. But just a word of warning, and the way you get around this is just make sure that the CephX users that you're using are unique. That could just be like a random string that you're generating or a UUID. So besides that, I think, so this networking being an inflexible part of your thing is a big consideration for many large deployments, especially if you're offering a service cloud or a public cloud. You are probably not extending your Ceph public network to your end users because you don't really trust them. So that might be one reason why you're going to consider gatewaying CephFS with NFS. And this, like Carlos was telling you, is getting better and better with newer OpenStack releases and with newer releases of Ceph itself. So right now, what we're talking about, and we've spoken about this a lot, in the OpenStack Z release, we added support to be able to export NFS natively. And this NFS happens to be the NFS Ganesha orchestrated directly on the Ceph cluster. Or you could denote certain nodes and create an active NFS cluster. and export via OpenStack Manila. And what that does to you is it increases the availability of the NFS service itself, and it also allows you to scale a little bit in terms of if you have a lot of different users and their shares gatewayed through a single cluster, you now have those serviced by individual servers, rather than having all of them gatewayed with one server, and you're hitting scale bottlenecks there. And the way internally that works is the NFS service is living on the Ceph public network, except you then allow it to export on a different network. You can isolate that network, you can call it an NFS network, you can extend that to your end users, you can create any number of NFS networks and partition your end users and so on. So that allows you to give your untrusted end users access to their to your Ceph cluster in a better way, in a more secure way. And then there's this aspect that NFS has been around for so long that it's a lot popular. So a lot of client tooling has been around for so long. People understand how it works, and so it's probably more familiar when you're offering this as a service on a cloud, for instance. So that's the deal with NFS. And let's see, we had a small demo at this stage. I hope that. So just shows you a little bit about of the internals on, okay, spinning circles. Yeah, hoping that loads. Oh, it's loading off of the internet. No wonder. All right. All right, hope that's legible. So we're just listing OpenStack Manila services. We're looking at the pools that we have. And in this case, we have two pools, a multi-backend setup, which both CephFS native and CephFS NFS. And we're looking at the share types that we've created. So this is how we're partitioning people on this example cloud. We're going to give some select people access to Ceph native and some others Ceph NFS. And this is what we would do. We've just created a share. That's what the share looks like. And that would be the access control for the share. We've provided access to a random subnet. In this case, a client is probably going to access that share through that subnet. Just means that nobody else has access outside of that subnet. And that's what the Manila site configuration looks. It's pretty boilerplate, pretty straightforward. Manila just needs to know how to connect to the Ceph cluster and what the file system on the back end is called. And when you look inside Ceph, we have two separate file systems partitioned off. And so that comes with its own set of data and metadata pools. And if you're looking at the Ceph orchestrator services, you're probably you're going to notice that each data and metadata pair have their own set of MDS services. And they also have, there's also the NFS cluster there. And then there's a subvolume. How did that come about? Because we created a share through Manila. And that ends up becoming a subvolume inside CephFS and all of the goodness out there on how to use that with the subvolume interface. The funny thing about this was not too long ago, this really nice Ceph CLI didn't exist. And it's getting better every day. So here's a NFS export that Manila created. When you set up that access rule, that's what it looks like. That's the client rules that it's applied. And that's how access control is done from an OpenStack cloud into a thing. So as you saw in the presentation, you could, let me just switch back into the presentation, if that's possible. Oops. Sorry for the hiccups. Let me just. Oops. Did I just kill the presentation? That's all right. So that was the short and simple of how things work in the cloud once you've set things up properly. Did we just do that? Yeah. So what's next? What is the Manila team working on, and what's the CephFS team working on? Well, right now, for the last few releases with the OpenStack Nova team, we were working on VirtIOFS, and that's now available with the epoxy release. Except if you're looking for a Manila CSI integration, that's not there yet. So that's coming soon too. What does VirtIOFS do? So a lot of people find that adding NFS gateways in front of CephFS is not really performant or scalable to their cloud needs. And so they were looking for something like VirtIOFS, where the mounting of CephFS is hypervisor mediated. So it looks and feels a lot like Cinder volumes. So you can trust your compute nodes. And so you'd give them permission to mount your CephFS and then expose it as any regular file system inside a guest kernel. And so that's possible from the epoxy release if you're interested. And we're also working on CephFS via SMB for folks that are bringing in a lot of Windows workloads from VMware. This might be of interest. And the NFS Ganesha community is working on adding QoS controls to NFS Ganesha. So at an export level, you can specify QoS controls for bandwidth and IOPS. We're also working on Barbican integrated user-defined encryption. So you can encrypt your CephFS volumes along with managing the secrets of this encryption via OpenStack services. And on the back end, the NFS Ganesha team is working on auto scaling and recovery. So today, if you shoot one of the Ganesha servers down, there's a particular process of recovery that ought to be followed through a manual recovery, and that should be getting better. So there's this auto scaling work that's going on, but it's slow at the moment. And finally, Kerberos. I think this has been on the wish list for a lot of people with respect to NFS. So that's something that we'll be integrating with OpenStack Manila. With that, that's the end of our presentation. And I guess if you have any questions, we'll take them now. Thank you. Check. All right. Sounds like no questions, but if you do think of anything, we'll be right around in the hallways and such. Do come to the OpenStack PTG and see us. We'd love to know how you are using OpenStack, and in particular with how you're using CephFS in Manila. We'd love to see what use cases are there that we're not looking at the moment, especially in terms of what's coming next. Thank you.
Hello? We're just giving people a few more minutes to walk in here because there was another session going on in the other room, so we'll get started soon. Hello, everyone. We'll get started now. So it's my distinct pleasure to introduce the next speaker, Todd Robinson. He's the president and co-founder of InMotion Hosting and OpenMetal, among many other brands. Todd is kicking off the first of the AI sessions at this year's event, and he's going to talk about private AI and CPU and GPU inference.
Cool. Thank you, Sash. All right, so I'm going to start out the AI discussion with a disclaimer. Actually, I got two disclaimers in here. So first off, this is not my deck. The proper engineer was not able to make it, so I will try to do it justice. The other one is, I use this as an example. So if you guys don't mind, grab your phone there. And so I've approached AI from a lot of different directions over the last couple of years, whether trying to learn it myself, whether as part of the business, whether as an infrastructure provider. But I always want to say something like this. This is still in the early days. So, but I use this example. So if you want to go on your phone or your favorite AI, ChatGPT or whatever, and look up what's the best way to take my kid's temperature. So grab your phone really quick. So you guys can help me out because I was warned by Sash to not actually answer the question the way that AI answered the question. So as you might imagine, for those of you, if somebody just wants to raise your hand and you can say it out if you'd like. It has gotten better, but the first time that I did that, I was like, oh, my kid's 11, and so yeah, that's not cool at all. So that's my disclaimer to get us started, because AI is still in its early zone. So yeah, I see a few people who have looked it up and said, yeah, I probably wouldn't say that out loud. All right, so. Yes, so yeah, it's all right, people still getting there, all right. So a little bit about InMotion, I'm sorry, a little bit about OpenMetal, and then we'll dig into a couple of these things around private AI. I'm gonna spend a little bit of time on the virtual GPUs, but we did that talk actually not too long ago, so we got a QR code up there for more in-depth details for vGPUs. Yeah, and then a couple other things that we got up there. So, but a little bit of background on OpenMetal is, so OpenMetal was founded out of a company called InMotion Hosting, and at InMotion Hosting we were utilizing OpenStack and Ceph for many, many years. And in fact, we had multiple versions of OpenStacks in various different parts of the business. And so we said, hey, you know what, this is pretty complicated to have this separated. Let's consolidate this down, let's make a standard system. So we partially did that, and as we did that, we realized, like, look, I'm a big open source guy. I got into the world of like CGI with Perl back in the day. But I was able to change from being an engineer, an automotive engineer, over into the computer science world. And so I have this real fondness in my heart for open source. But we had been using Ceph and OpenStack for many years and had realized, you know, we were able to architect new, fresh OpenStacks with confidence. But one of the barriers for OpenStack was the ease of adoption for this system. It's very complicated, and if you're architecting it for the first time, and you had never been like an administrator of a really good OpenStack, you're really setting yourself up for some difficult days ahead. And so what we decided was, hey, actually, since we can productize this, we're also a hosting company, we've got hardware easily on demand. So essentially we figured out how to spin up a 3-server hyperconverged with Ceph, highly available 3-cluster system, and basically just spin it out almost instantly. It actually takes like an hour. It takes maybe 45 minutes to 90 minutes, depending on the servers themselves, to warm themselves up to that state, you know, from ironic all the way up. And then it comes out and it's finally injected with your last customer details, and then it's handed back to the customer. And so to the customer's perspective, it's literally 45 seconds. It's just injecting the final pieces in. So that's what we do. That's where we sit in this space. So let's see here. This is the team that would have been speaking today. Unfortunately, yeah, so if there's any mess ups, the guy on the right over there, that was him. No. So actually, Rafael Ramos, who's up there, very, very, very talented and has done the bulk of this work. So I unfortunately don't get a whole lot of time on the keyboard directly with this stuff, but I'm very familiar with it both from being in an open source, AI-centric startup and having experience from that side, being a hosting company, as well as being an infrastructure provider, and of course a user myself. But yeah, if you want to get a hold of either of us, we are up there. All right, so quickly, what is private AI, or my perspective at least on it? Yeah, so this is you doing it yourself on your own systems. You can absolutely use CPUs and GPUs. You should, as you go down the AI world, you're of course going to need to have a deep familiarity. So I wanted to touch on a few of these things as we go through them, but there's some of the obvious ones is, data privacy and security. But I also like to say, it's not up on there, but I also feel like when you're doing it yourself, or you're enabling your company, or you're enabling your customers to do it themselves, there's a certain amount of velocity that you can get out of this because you actually understand it. And it gives the team, your teams, yourself, different directions that you can take with it. So again, I'm a huge advocate of private AI. This shouldn't only be out there with the mega AI companies, or whatever we want to call these mega companies nowadays. So I listed down there, fundamental understanding is you'll get this familiarity, but I would also say if those are foreign things to you in the AI world, you want to go learn about them pretty quickly here. So yeah, the model resources versus capability versus cost, that's going to come together for you. You need to know reinforcement learning, quantization. This has obviously happened in the last year and a half, 2 years, where the companies have really realized you don't need to run these models at extreme precision. Floating point 32 that's up there is like a lot of math that wasn't really necessary, and so a lot of the models have been quantized down to int 8, which is a much more reasonable way to go about it. Yeah. So distillation is that's one of my favorites at the moment, but that's essentially when you take a pre-existing model and you can run it through basically an educational process where you train, as you transfer the information, you're training specifically against something that you may want, and essentially you can take a really large teacher LLM, which might be running in memory at, 80, 100 gigs, very, very large, not practical to really run, except for very specific spots, and you can drop it into a student LLM, and so this might be like a Llama 3 something quantized, and maybe quite small, and it'll turn out to be like maybe 3 gigs in RAM. So something, these are areas that you're going to want some familiarity in. Mixture of experts, it's been around for a little bit. It was popularized and brought kind of focus by DeepSeek recently, and that's essentially, they have this monster model that, actually it's kind of funny when DeepSeek kind of came out in the public eye, and you saw NVIDIA tank stock, and then like 4 or 5 days later, NVIDIA releases the NIM that's specific for DeepSeek, and you can only run like the full DeepSeek thing on some giant cluster. It's a huge model. It's really large. Yeah, so if you can see, the original model is a very, very large one, and essentially you have to use these huge systems. Now, if you're distilling it out of there, yeah, you obviously can get to a much smaller model. So mixture of experts is pretty cool stuff. Let's see here. Okay, so yeah, tipping point. When is private AI viable? And I think the biggest lesson here is that as the models become easier to use and the kits are more standard, so some of them are listed up there, NVIDIA NIM, for example, Llama VLLM, as these are more and more standard, they're just a lot easier to use. They're a lot easier to pull in, and so I've even watched some of the developers essentially flipping back and forth between using OpenAI's API and flipping to a local LLM trivially within their applications. And so they're really just getting a lot easier to learn and to use. But still, you're going to still want to have some of these fundamental understandings that I'd mentioned before. So one of the things we're going to actually cover really quickly today is that to help people have really ease of access to it is that these models have gotten small enough where the CPUs are starting to become viable for many use cases. So it doesn't mean your fastest use cases, it doesn't mean your most demanding use cases, but it does mean that it's possible and people can learn on it quickly. That one I think I might have run through already. All right, yeah, so over on this one, Yeah, again, GPUs, of course, are really king for training. You're not going to get around that, but unless you're, the $100 billion company, you're probably maybe not even into that game. Certainly you can do it, but in most cases we're talking about inference. And so inference, we have now found, so we do this on several, I'll get to some tests here in a minute, but we do this essentially because different customer models can require, hey, let's say I need a suite of developers to work on something. They don't need these super fast systems. Or let's just say I'm using a very simple chatbot. Well, do I actually need something to be as fast as an A100 or an H100 or an H200? So almost typically we're talking about these particular GPUs, and so I grabbed this the other day. They are fast. They're pretty incredible machines. I'm a hardware person myself, but yeah, I grabbed some of the rough prices that you might expect out there without giving our exact prices that we pay. But yeah, an H100, you're north of 25K a piece. The A180 gig, you're north of about 13K right now. So if people are getting better prices than that, please come talk to me later. I'd like to know about that. But they're super fast, but they're incredibly expensive. And that's just the card, right? Like you got to put it in a box. You got a box around it, and that box is going to be a high-end box because it's got to handle all this power that's actually running through this stuff. So people kind of laugh at me like, you definitely have the 1 kilowatt, 1.5 kilowatt box, and people just start looking at that and going, okay, this is a real challenge to actually handle all this. So again, you want to make sure you understand some of your use cases because it can really have a long effect all the way down the line, into the data center, into the rack, and trying to get the sufficient cooling for it. And sufficient cooling then can dictate, all right, does it have to be liquid cooled? Can it be air cooled? Do I even have space in my liquid cooling or in my air cooling space? All right. So this one, yeah, so just really quick, this is what we have run through before. The QR code up there will actually take you to our previous talk. So I wasn't, again, myself not being close enough to it, I can't take you through the demo like they would have. But that's got the, where we actually did the virtualization, and this was a talk at a previous year or two's. So MIG is essentially where you take the card and slice it up into virtual, and you can do it, it's typically right around the 7. So like I've got the example up there. If you're doing a 40 gig, you can slice it up 7 times, and you end up with a GPU that's got 5 gigs of RAM available to it. And then of course you can attach the VM directly to that. These things are all done relatively straightforwardly inside of OpenStack, and again, the other video there covers that. You got to watch out. The MIGs are only available A100, H100, H200. And you have to use time slicing for a lot of the other GPUs that are out there. We're not as familiar. We don't actually do that as much. It's actually more common for us to attach the GPU directly to a VM, or somebody maybe is using it bare metal, or to use MIG. Of note, I think they still require, there's licensing that is associated with that. I've kind of lost track of what, so the licensing has been around for a while, so you have to set up this licensing server, which is a bit of a tricky thing. But I do know that some of the Intel GPUs that are coming out are not licensed that same way. So I think that maybe it's my own wishful thinking, but the community is hopeful that some of this licensing stuff will go away because it's an added layer of cost and complexity. All right. So this one actually, so this is really intended just for, I don't know if you can actually take a picture of that. That's actually what you can do to get MIG running. So I don't know if that's something, of course, you'll be able to look at and see inside of the deck later. But that's essentially, this is our developer, Raphael. They're helping me out with what it would have been like if he actually was able to run that demo. All right. So I'm going to jump then to just the CPU, that pretty much everybody's familiar with the GPUs and being able to run these workloads on GPUs. So I'm going to actually spend a little bit of time on the CPU. And in this case, this is Intel, so I'll just cover that one today. But essentially, in the 4th generation, they added some specific silicon. You can see that up there, TMUL, if you need to look that up. But essentially, it's AMX extensions. In the 4th generation and the 5th generation, now give you specific silicon accessible by each of the cores that can actually run some of these calculations for you. So you may remember like back when Intel added like to do encryption, right? So it's very similar to that. This is a specific silicon to handle this workload. Right now, we only run up to the 5th generation. For those of you tracking Intel, with the 6th generation, the P cores will have this, but they're very power hungry. They're really big CPUs, partly because they've been putting all this stuff in it. And so we haven't actually made our shift yet to P cores, to the to Xeon 6. So I'd love to, if anybody's got their own opinion on that, maybe find me afterwards. I'd love some advice because it looks like they're both going to be tricky to get into boxes and quite expensive. And again, it's just the power envelope. When the power envelope gets too big, it gets pretty hard to get in a chassis. So let's see, hopefully this will play. This is just, so I'm going to switch over now to when you're setting kind of expectations for, or requirements for your, oh boy, I can't see that. Setting requirements for what you might be trying to do with your workloads. All this really is just, you can see, right, labeled up there, 25 tokens per second, 50 tokens per second on the side. The point that we're just trying to make here is that when you're a human and it's a human interaction with an LLM like this, your 25 tokens per second is plenty fast. It's faster than what a human is going to be able to interact with it anyways. So it helps you just give some perspective about like, well, what am I actually going to need to design against? And so I know I'm switching all the way between like data centers, you know, and power issues, and then all the way to like end use cases. But the reason for us that we end up doing this is when we as a company are learning our new technology, and again, I'm 100% Open Metal is very much in that stage, is we like to talk directly to the customer and figure out what you're doing and understand in depth what is the issue that you're facing. So in some cases, we're down at this level going like, well, what are you trying to accomplish out of this? So like recently, we're having somebody come off of AWS using their natural language tool, Transcribe, AWS Transcribe, and it's a huge bill that they have, and we have to figure out, okay, you got to get off of that. Their business model is not going to sustain that. It's now put us into the natural language processing and us understanding how to use Whisper in order to accomplish these similar things for them. But that's, I say, like, so for us, hopefully this is useful that I'm switching, you know, back all the way down to the data center and then back up to use cases. Yeah, but so again, that was trying to show you that when you set your requirements, it can often help you go, okay, is this going to be CPU? It's going to be GPU. Where are we going to be with this? All right, let me see if I can get myself moving again. Yeah, so again, so this is kind of following that same vein. The developer only had an A140 gig available to run these tests on, and then running them against the CPUs. But you can see up there, you'll end up with getting familiar with tokens per second. This is, you know, just what the system can handle, how fast it can actually push these requests through. So in this case, I've got a few tests that I'll flip to, but 30 tokens per second, you know, chat, code assist, document summary, these are often human interaction related things. And then if you're over in like fraud detection is one we were actually working on recently, is you end up actually having to have really high throughput. So in that case, you know, maybe something like a CPU is not going to make sense for you and you're going to be over on a GPU. It's starting to become a little more common where people are using systems that make multiple calls to the LLM before it comes back and shows the human, you know, what's going on. So you got to account for that. So in that case, you might be processing 2 or 3 times, and then you're going to end up in the higher processing tokens per second requirement. Some of the other things to watch out for, yeah, accuracy level requirements. Actually, one of the engineers that we were just talking. He was trying to use one of the smaller LLMs to produce some JSON, some pedantic JSON data set, and couldn't get the lower accuracy model to actually produce it accurately. And so it would have syntax errors inside of there versus the higher cost one, more accurate one was producing it correctly, reliably. And so there is trade-offs, so certainly you're going to find out as you start to work with these. But I would encourage you guys to have the models available to you to flip back and forth. Then you can make decisions like that to say like, no, actually it works fine for this business model. Right. Something to always note about the CPUs is, of course, these are general purpose. It's a CPU. And so you may already have lots of unused CPU in your systems out there. So this is not uncommon that people end up with a lot of CPU. Run out of RAM in your OpenStack, but you've got a lot of CPU left over. So it might even be that you've got resources that you can use now. So kind of free in that case. All right. So I don't really know that much about that one right there. So we'll have to move through that one. All right, so here's some other things that we found. So now I'll get to share with you some of the stats that actually came out of the testing. So in this case, why exactly it's doing this, I don't think I can speak exactly to what that is. But as you can see here, that in some cases when you, and again, this is Llama 3 billion quantized down to 8, is that the tokens per second actually was performing highest at utilizing 64 threads or 32 threads. It's a 128 thread box. And I think we're still trying to puzzle out what those could be. It could be that these are also the governor is set to performance or what the schedule util. Don't use on demand for this. I mean, you probably may know that already for various use cases, but that's going to give you a penalty hit because it's trying to shift itself up and down performance-wise, so don't use on demand. But yeah, as you can see here, you may end up figuring out like where your sweet spot is inside it. It's going to be CPU specific, and then we've got 3 CPUs that we tried it against just to be able to show people what they might expect. Just for fun, he was kind of switching the AMX on and off on there. Yeah, and you can see we tested the 4510, the 6526Y, and the 6530. And again, we ran it with half the threads only whenever we were doing this test. And then you can see the top number there, for example, on the 6530, it was running 53 tokens a second. 46 with the gold. It's considerably less threads, but actually that one actually has a higher clock speed than the 6530. So those are 3 pretty common CPUs that you see out there. You guys probably might have them in your clusters already. Yeah, he ran this again, so you can see something similar. This is for one of the distilled DeepSeek models. Yeah, and also you could just see the difference there. It is kind of interesting, again, that particular CPU, the 6526Y, that's turned out to be like a workhorse for us. Very popular with our customers for a whole bunch of different purposes. All right. I'm gonna read you just a little bit of this because this was some good findings, but again, I'm not as familiar with this stuff. So, Llama CPP, yeah, lightweight this was definitely one that this is Raphael, sorry about that, that's his favorite now. There was some tweaks that had to be due to it to get it to really efficiently run on top of CPUs, but that actually turned out to be something that he is now turning to regularly. And Intel, PyTorch, of course up there, OpenVINO. If you're not familiar with OpenVINO, that is Intel has put that out to be able to access, these are the libraries, to be able to access the stuff that you need on the CPUs. But that's Intel's toolkit. All right. This is just kind of helping you understand where these fall in comparison. That is the A100 and what it can process, 171 in this case. But again, this is that particular one with the 40 gig, I would guess, was probably like it's probably $9,000 or $8,000 or $9,000 if you're buying it now. And again, that is just the GPU itself. And so whenever you're looking at this stuff, you're going to be balancing the cost versus what the thing can actually handle. All right. Yeah, this one is just, again, reminding us that this is in flux, this is changing, so the skill sets of these open source, this is off a Hugging Face, so it probably should have be quoted there. But this is just essentially how the accuracy of these models are increasing, but they're also becoming lighter and lighter weight. And as that happens, that frees you up to be able to run these in a lot of different places. It could be CPUs, it could be multiple instances running on a single GPU. So something of importance, when you got a small model, you can of course run multiple at the same time on GPUs. All right, this one, so I'm gonna, if you guys don't mind, I'm gonna turn a little philosophical here. But actually we have one of our customers, and it's a company actually that I work with as well. It's called OpenMaya, and it's also, the application's published under circlebot.ai. And just open metals always have this philosophy of simplifying open source, large scale open source. And when I look at the ecosystem that's around AI, it's a pretty complicated ecosystem. And so I was excited like that where we may be able to sit as a open source community is both in the OpenStack world and just leveraging like the philosophies that we all have in the OpenStack world. How do we apply these to the AI world? And one of the things, and we were just having this discussion at lunch, so is that, you know, a lot of this is currently dominated by very, very large organizations, like very large, and only getting larger, you know, if it keeps going this direction. And for me, when I think of OpenStack and where we can fit in the AI world, partly it has to do with the community. Is the community is one of these rare communities that has the ability to have a scale that fits and can fight against some of these larger organizations that to me feels like they're gonna really try to dominate and drive forward the utilization of this stuff. And sometimes you even hear this like, oh, whatever Altman there's got to say about it's time to, you know, replace your developers with this AI kit that they're putting out. These kinds of things. This doesn't seem like a great thing in the world. And so for me, when I think about OpenStack, open infrastructure, and this community around there, is there some of the things that we can do as a group to help bring AI to a democratized, for lack of a better term, to help people be closer to it, to learn it themselves, understand the business models, and to be able to change directions of the larger group, to support, hopefully, what I would call like the non-big AI business models, and let people be closer and more fundamental with AI. So, yeah, that's what I had to say today. So, yeah, just one last thing, if you guys want to get in touch with any of us or just kind of keep up with what's going on over at OpenMetal as we're starting to roll out our AI products. Hopefully this stuff was useful, everything, you know, again, I touched from a data center, you know, all the way up to, you know, tokens per second. So, all right, this is, again, this is the crew over there that you could get a hold of, that's kind of front facing. Raphael and I, and Raphael, sorry he couldn't make it, but I know it's recorded so he can watch me talk about him later. Cool, all right, yeah, that's what I've got for today. Is there questions, or I think we can wrap it up. No questions? All right, who wants to tell me what they looked up and how to take the best way to take the temperature of your child? We'll circle back to that. Cool, okay, no, thank you very much, and again, please come and chat with us. Thank you.
Hello everyone, as usual, what's a session without technical difficulties? But we are about to get started here. I'm happy to introduce OpenInfra Day's spotlight sponsor actually, Lightbits Labs, Sergey Volkov, Distinguished Technical Evangelist. And he will be talking about optimizing your platform architecture for VMs in OpenStack and OpenShift.
All right. Oh, this is loud. I have to speak very low. All right, so hi everyone. We got 10 minutes to introduce you to Lightbits. So I'll try to make it really fast. Lightbits Lab is the company. Lightbits is a storage. It's a software-defined storage solution. And it's basically built on a foundation of 3 things. The first being NVMe over TCP. NVMe over TCP is a protocol that we invented probably about 7-8 years ago and donated it into the Linux community, let's call it a network community as well. And it's basically the method of running NVMe commands over TCP, over the TCP stack. It's part of the Linux kernel since 4.10. And so on pretty much any Linux distribution that you're using today, you already have the kernel model for it. We invented the protocol. The key about Lightbits is that we wrote our software for storage to utilize NVMe TCP to the max. Other storage providers today are also providing NVMe TCP access into the storage. The key difference is what you do below the network stack at the target level. The other, I guess, part of our pillars is that we wrote our own flash translation layer, which exists on any of the targets that run our software. What it basically means is that we know how to utilize better SSDs, how to enhance their lifespan or life cycle, and how to make sure when writes are occurring that they are only written into the right and best areas on the NAND devices. And the third pillar is clustering. So this software runs on any x86 server. All you need is servers with NVMe SSDs in them and network cards on these, and we will cluster everything together and represent all the capacity of all the SSDs as if it's one large logical chunk of storage. This is basically how it looks. Explain a little bit about NVMe over TCP. Each client, whether it will be bare metals or OpenStack or Kubernetes, are just using the NVMe over TCP protocol to access the targets, and they are completely aware of where the targets are, new targets that are being added. Everything can be done on the fly. We support, again, because it's over TCP, if you want to do bonding, anything that you want to create over the usage of the TCP layer, you can do it. We don't really care about the type of network cards, type of switches, any sorts of flags that you create along the way. That's a very, very detailed, I guess, explanation of what actually runs on the target. And in very short, our backend processes are the ones that are doing the flash translation layer. We're also doing local erasure coding at the target level. So you are protected from a failure of an SSD. And the encryption that we're doing is also being done at that portion. Front end is where we look at all the traffic that is coming from all the clients, aggregating writes that needs to be done, pushing them into the right place. Also replication that is being done at the volume level is being done from front end to front end, basically. One of the key things in Lightbits is that you can actually decide the number of replicas that you want a volume to have. So it can be either 1, 2, or 3 replicas. When you create a volume, you basically decide on that. This is kind of a very messy and massive slide on where and what we support and run. So we literally have customers. Some of them are running in cloud. A lot of them are running on-prem. Platforms that are using the storage. We are the first NVMe over TCP driver that was created for VMware. No, it's not a welcome name in this conference, maybe. But we have a CSI driver pretty much from day one of the company. Most of our customers are running Kubernetes. Then some of them are running also OpenStack. In terms of the application themselves, most of the times we don't actually know what the customers are running. But from the big ones, we know a lot of it is leaning towards databases or any kind of IO-intensive applications. These are some performance numbers. On the right side, these are IOPS. What you're seeing is actually 3 servers of Lightbits. Each of them has 12 SSDs. And you can see that IOPS in terms of read-only 4K, about 14 million was done from just 3 servers. That gives you roughly 4-point-something million per target. If you need more, you can just add more targets into the Lightbits cluster. You can also see on the left side some samples of latency numbers that we get. Of course, lower on the IOPS, but you can see also almost 4 million 4K reads with 99 percentile of, 292, which is really impressive. And I got 90 seconds. This is some performance numbers comparing Ceph using OpenStack. What you're seeing is basically VMs that are running inside, several VMs that are running on several OpenStack clients, all utilizing a 3 nodes Lightbits cluster. And you can see with the one OpenStack client, the number of IOPS, it starts to increase about 4.2 million from 4 OpenStack clients. Pretty much stays over there. We need more IOPS. We'll just add more targets to the Lightbits side. And I think this is also a comparison that was done on via a third party, trying to understand the impact of using Lightbits storage together with a flash translation layer, comparing QLC and TLC media SSDs, and basically showing that even with the slower media like QLC, we still get the very good performance because of the flash translation layer. It's also a comparison between Lightbits and Ceph. There's a big gap. And that's it. I don't know if anyone has any questions. You can ask now or just come and talk with us. And we also have a table right after the rack space table outside. Thank you.
Coming through? Okay, we'll give it a minute. Other people are coming over. Like you have 3 minutes before you have to start.
That's all right.
So, yeah.
Huh? That's okay. You can just stand here for a bit. Take this off. Yeah, that's a good idea.
So we still have a talk here in just about 2 minutes. We're waiting until it's actually close to on time. Ooh, 60 seconds. Yeah, nice little countdown. Okay. So I'm going to go ahead and start and just introduce you, and you can kind of get started. So up next with the next talk is Simon Dodsley coming from Pure Storage. He's going to give us a little bit of background about Pure Storage and integrations with OpenStack. Pure Storage was our coffee sponsor today, so thank you for doing that. We all feel a little bit caffeinated as a result, so thanks, Simon. Thank you, Pure.
Hello? Oh, there we go. Thanks, Billy. Hi, my name is Simon Dodsley. I am Director of Open Source Integrations at Pure. Been with them for like 11 years now, working on OpenStack all that time. You can find me at theanswerguy.com. But before we start, the first thing I want to do, if this thing works, no, it's not working. Yeah, there you go. Yes, happy birthday to OpenStack from another 15-year-old. So Pure was 15 in October last year, so from one 15-year-old to another, happy birthday. Just get that one out of the way. So I think a lot of people may have heard a little bit about Pure Storage. Some people may not have heard of us at all. So just a quick intro of who we are as a company. We were founded in 2009. We are the fastest growing enterprise storage company in history. Our platforms are based on all-flash technology. There's no spinning disk or anything like that. And in fact, in our latest iterations, we only talk directly to the NAND chips themselves. So forget that flash translation layer. We're talking directly to those NAND chips. We have a number of platforms now that are designed for basically on-prem data centers. We can give you capacity-orientated, we can give you performance-orientated, we can give you something in between. We also have an ability to create a virtual version of a flash array in the cloud. So for AWS and for Azure, you can get a flash array that lives there. It looks exactly the same, it works exactly the same, the GUI is the same, all the software is exactly the same. It is a single operating system for every platform, whether you get the smallest or the largest or the one in the cloud. It's exactly the same operating system, same API calls, same everything. And I think one thing we've just announced, actually, we have continually had an NPS score higher than 80 for the last 10 years. This year we're at 81. The average for the tech industry, anyone know what the average for the tech industry is on an NPS score, a verified NPS score, anyone? Shout a number out. It's 40. But yeah, 10 would be even better for us. So I don't know this slide. The marketing people made me put this one in, so I have to read it while I'm talking about it. Again, over the last decade, we have been consistently proving our technology and everything we do in this space from a storage perspective. We're bringing down people's TCO. We're allowing you to operate your storage with less people, which means that your people you've got can go do other more important things than messing about with storage. We're incredibly reliable. We have 6 nines availability, which is a pretty good number, and we're getting close towards 7 nines availability. And the way we've architected the solution, we use a lot less power and a lot less space than other providers. So Pure has been working in OpenStack. We've had our first upstream driver was in the Juno release in 2014. We have been continuously contributing to OpenStack since that point. And we produced a Manila driver for our FlashBlade product that came out in the Xena release. And we've contributed to over 26 projects, and we're going to try and keep upping that number. We believe in the open source world. We believe in continuously giving back to the community, not just doing the stuff that's good for us. So we do write a lot of patches. We work on adding features to things like Nova and what have you as well, things that don't necessarily mean anything to the Pure platform. We are the only vendor that is fully certified to use all of the block storage protocols supported by OpenStack and the OS Brick project. And we're integrated into many different deployment methodologies, whether that be Canonical or Red Hat, Mirantis or Cola or whatever it might be. And we are actually the only NVMe TCP platform that's certified by Red Hat OpenStack platform today. And we're also one of the preferred storage platforms for canonical OpenStack. So this is a couple of pictures of our platforms. This is the flash array. So we have the flash array for the Cinder project. We have the FlashBlade. I've not got any pictures of that there. For the Manila project. If you take Ceph out of the picture, based on the OpenStack surveys, Pure is number 1. The flash array is number 1 for Cinder globally in OpenStack after Ceph, which is pretty cool. And the reason is you're looking at things like you're getting an average of 5-to-1 data reduction on our arrays. Okay, those arrays are capable of doing really low-end work to really high-end work. And you can get so much packed into such a small space as well, as we're mentioning. So one of those you can see there, I think it's the flash array C. You can get 9 petabytes in 3 RU, which is pretty phenomenal, really. So the nice thing about our arrays as well is once you bought one, you never have to migrate off it. It's there for life. We can upgrade on the fly with no downtime. We can upgrade the controller to the next generation of controller on the fly with no downtime. And we've proved that numerous times. So from a Cinder perspective, we support all the features you would expect. We have active-active support. We could do full replication support, synchronous, asynchronous, even 3-site replication. We're the only vendor that does 3-site replication at the moment. We have front-end quality of service. In fact, we're looking at expanding that in the epoxy release. Full snapshotting capabilities. I'm not going to read all these out. Oh, the one that's really interesting, in the epoxy release, we're actually adding support for vVols. So VMware vVols are going to be supported, which means if you are migrating from VMware to OpenStack, you can just grab one of those VMware vVols and import it directly into Cinder. Create an image, bang, the system will boot, and you've moved your system over, transitioned it completely within seconds. And because of all the features we do have, you can have a Ceph-less OpenStack cluster. Okay, the things that we do, or the integrations we've done with the flash array, not even necessarily even with the FlashBlade as well, but the flash array, block storage, file storage, glance integration, Swift support, Nova ephemeral storage, all of those things are available today in Ceph. They're also available today in Pure Storage. Okay, things that Ceph doesn't have that you might find quite interesting. Keyless data at rest encryption. Yes, Ceph has encryption, but you have to link it with a key manager. Pure does it keylessly. Ceph doesn't have that replication capability that Pure has. Ceph actually also doesn't do front-end quality of service. It can utilize back-end quality of service with KVM, but it can't do it itself on its own front end. And also, Ceph doesn't do consistency groups, which is also really interesting when you start talking about databases and running those on OpenStack environments. Consistency groups become incredibly important when you're taking snapshots. And also, with Pure Storage, you don't have to actually manage the array. You don't have to worry about it. You never need to log on to it. Whereas with Ceph, you basically need someone with a PhD in Ceph to keep the thing running. So that was a really quick overview of OpenStack. We have a number of partnerships with the big players out there like Canonical and Red Hat, Mirantis, IBM, and a couple of the other smaller guys. I don't know if people have heard of Breakwater, based in Canada, and Virtuoso, who are based in Switzerland. And we're looking for more OpenStack partnerships. You know, there's a couple of people we're already talking to. I can't put their logos on the screen today. But we're actively working on OpenStack partnerships as we move forward. And if you do want more information, please come see us. We have a booth over by the stairs on the far end, left-hand side. Happy to chat, happy to talk about anything I've said here, anything else you want to learn about Pure Storage. We'll talk to you whilst you're enjoying your coffee. I don't think there's any left now. I wrote this before I knew when we were related to the coffee session. But thank you very much for your time, and enjoy the rest of the sessions.
Wow, that was awesome. So 30-minute break, and we're back in here at 4:30. So stretch your legs, get some air, whatever you need to do. See you back. Okay, we'll get started in about 1 minute here.
Okay.
Yeah. Wow, it's 4:30, so we'll go ahead and get started for you guys. Okay, so we are back here for the next part of the OpenInfra Days. We have Vivek and Ambi presenting us some information about SONiC and OpenStack together, so looking forward to it.
Hello. Okay, so how many of you heard about SONiC as a network operating system? All right, so a lot of people, glad to know that. So here, it's myself, Vivek, and my co-founder is Ambi, and it's a very new company. It's very young, so 2 months old, and last week I left my job and joined this company. And here what we are going to do is we are going to share some of the work that we did, part of the community initiative. What we did is we took OpenStack as an edge cloud or a co-located data center, and we took a metal server, x86, and converted that as a L2 and L3 switching platform using SONiC and VPP as a data plane. And we were able to achieve multi-cloud connectivity to have a seamless connectivity between VMs running on OpenStack and the VMs on Azure and AWS. So that's a story that we are going to share now, what we did, and I'll walk you through the journey that we took. So before I go, so these are the community members. Me and Ambi is there, and Tom, Julio, TRB, and Mitchell. So we are all the community contributors across the globe, and some of them sit in Latin America, some of them are from Europe, and I'm from India, and Tom is in US. He's from CA actually, he couldn't make it. Basically what we do is like, we have been contributing to various different projects across Elephant. So starting from OneApp, OPNFE, Acrono Edge, that's part of the LFH initiative. And SONiC FIDO has been there for a very long time, you know that, right? So, and OpenStack. OpenStack I started in 2010 when I was with MLX, so that's where I got introduced with OpenStack, and Ironic was the first project that I was working on. And writing a BMC firmware which boosts the server from an ISKC target. Okay, so that's the initial work I did. And basically it's a global team of contributors coming together. Okay. So what's the problem we were trying to solve, right? So, achieving real-time multi-cloud connectivity is not simple. It's a very complex problem. When you have compliance requirements to have your data and packets to be, located in a particular region or particular, metro, and nobody wants to do the networking job, right? It's if you look at it, right, everyone would love to become a full stack developer, right? Now everything is full stack or DevOps. If you ask anyone who wants to become a networking engineer, you will not see many people, right? That's a dirty job, I would say. Everyone thinks, maybe. So, again, achieving the low latency and data locality is also critical, okay? So that's a very important aspect. So again, it's complex and expensive. Why it is expensive? Because multi-cloud is not simple, because you need to have a domain expertise from multiple different areas coming together to solve a problem, right? How many of you realized multi-cloud connectivity in real time or as a developer? Did you ever try that? Have you ever tried, any one of you? Because in any organization, if you go and ask that you have an ITIL process, you have different systems managing different infrastructure, right? Create a ticket, it may take you a day or it may even take you weeks to get to even realize the multi-cloud connectivity, right? So that's why the problem is more complex. So solution, what do we, how do we solve this problem then, right? So basically, it's again the mindset, right? So embracing open source is very critical because we have very solid proven blueprints available across multiple different open source projects. So that's also a challenge, right? You will not be able to find experts who even, can help you to set up things because again, you have to be compliant with your internal ITIL process and other things come into play, right? So what we did is, this actually we did it for one of a customer who came to us for a problem to be solved. So that's when we started looking at it. And we took OpenStack and deployed it as an edge private cloud. And we took one bare metal server, x86 box, and then converted that as a switching, L2 and L3 switching layer with the data plane as a VPP. VPP itself can do everything today, right? So because VPP has got a data plane and it has got a control plane. It's very complex there because you have to go through the VPP CTL and understanding those terminologies is a bit more complex. But when we combine the SONiC control plane with VPP as a data plane, right? That greatly simplifies the way we program the network or the configuring the network because, everyone is used to, right? In the networking world, you do config terminal, right? Go to the config and then start typing your commands, right? Or you have a netconf, you push your configuration, right? So you have an Ansible playbook, push it, right? So that's where the SONiC came into play, okay? Because when we looked at it, the SI layer is so abstraction, such a way that it doesn't care whether is it actually making those API calls to an ASIC firmware or to a software library, right? That's pretty clean isolation layer, right? Switch abstraction interface, right? And that's the stack that we took it, and then we demonstrated multi-tenant and multi-cloud network connectivity using this platform. So again, so what is this use case is about, right? Let's look at this use case. The customer came up with the problem, like there are a large number of data sets, basically, satellite-based images, some drones doing some sonar scanning across the sea areas, they do some kind of lot of data analysis. Basically, these are all scientists who works on this field. So they came together and then, they have large amount of data. That's spread across multiple cloud environment, basically various different reasons for that because these are all funded by government agencies. So, but they would like to, collate all the data in a particular, edge data center and then run and train their models basically, okay, GPU-based servers. So this is where the problem started because this is where the need of connecting multiple different clouds came together, right? So what we did is we proposed, using Equinix as a co-located data center, and they have metal, GPU, everything, but the infrastructure for this POC was 8 CPU with 225 gig GPS. These are all on-demand servers, right? So you don't need to have a capital investment. You can just hire per hour basis, right? So we recommended that. And Equinix shared fabric port again, because these co-located data centers, you have a variety of service providers and port providers, right? You can have a fixed one where you will procure the port for a year minimum, okay, and 10 gig or whatever the bandwidth you are looking for. But shared for this particular use case, the shared fabric port meets all our requirements because. From the latency point of view and the throughput, you won't see a difference between a shared and a dedicated one. Basically, it's the same fabric that Equinix is going to dedicate a port for you. But only difference is the port is dedicated and you may have connectivity across multiple different metros. But in shared fabric, it will be only available in the particular metro actually because they're going to lease, time slice their free ports, right? When you have such a huge, massive data centers, right? You have a lot of switch ports sitting idle, doing nothing, right? And you get it almost like, I would say like 1/4 of the cost. And it is not
something that, going to have a huge capital for a year getting locked, right? So it's, again, pay per hour, actually. So monthly recurring charges, again, it will apply. And then we took West US as a cloud region between AWS and Azure, and SV as the Metro Equinix co-located data center that we took it. Basically, the experiment is to validate egress and ingress. Ingress, almost kind of a zero when you push the data inside through a private connection to a cloud. But egress still costs you, right? When you move data outside cloud, it costs you. If you go through the public, it'll be even more expensive, public network, right? So that's even more expensive. But here we were able to, demonstrate the value. And solution is, again, we took the SONiC control plane and VPP as a data plane because we want to process the packet at the line rate, right? If you want to do that, you need a data plane like VPP. And again, we don't have a physical NAS here, right? We are not talking about hardware switches. We are talking about a x86 server acting as a switch because 25 gig port and with a lag configuration, you get essentially 50 gig speed, actually. You should be able to process those packets, right? So again, we used Azure side for a private connectivity, express route, and AWS Direct Connect is what we used. And we used iPerf to test OpenStack VM to Azure VM, OpenStack to AWS VMs. That's what we did it. And again, AWS to Azure also part of the same network because now everything is talking to one single router. That's a SONiC, right? L2 and L3 is same, so they were able to, L3 basically, right? They were able to connect to each other. Okay, so what is the business value that we demonstrated? So basically, if you talk about this entire solution, right, it is like 1 PB of data in less than 48 hours that we could, transfer. Maybe physical switches could do much more, but here we are talking about the data that moves from node 1 to node 2, getting stored, and we purge this because we don't have such a huge storage box. What we do, we just bunch of files, we push it and then delete it. There is an overhead in the packet headers. A lot of things are calculated. So it's around 48. It's not exactly 48. It's much less than that. So that's a value that we demonstrated. Again, we took the blueprints from proven open source. Okay, look at the maturity of OpenStack now. Right, it's almost 15 years now. I started in 2010. Now it's 2025. I'm here. This is my first conference, SCaLE, by the way. Okay. And again, on-demand and secure connections from edge to your public cloud because there's no cost commitment. Think about a use case where you have backup schedules. These circuits comes up, runs your backup, and tears down automatically because we used readily available Terraform, Ansible, OpenTofu that you can readily use it, bring it up as part of your pipeline, backup pipeline, make the secure up and running, and tear it down when you don't need it because this is kind of a use case that one can look through. Again, significant cost savings. What we are talking about is huge in egress cost we are talking about because when we go through, think about like you have some data in S3, you have some data in Azure object store. You want to move this to your edge cloud to run some training because multi-cloud connectivity is not a fancy anymore, right? It's essential now, right? And especially in case of an IoT and AI, you can't simply depend on one single cloud service provider to give you everything because you don't have a matured model for your domain today. And I have a customer who came to me like, I have huge set of scanned documents. Ambi comes from an insurance background, actually. He has been working close to more than 16 years in the domain, right? You know the compliance requirements. They have a huge amount of data, right? And these guys say that, can you query all this, a million files I have? I want to query that. There's no single tool right now. So what these companies are thinking is like, why can't I use this file to train my own model so that I can query what I want actually, right? So those kind of use cases we are talking about in this. That's a business value that we demonstrated. This is a H2 multi-cloud connectivity topology. It's a simplified diagram, and everything comes on demand. And for this demo, we experimented, how much will it cost me to do it, because I'm a very small company, right? So it's like two of us, right? Can I throw $100? Yes, yeah, we could do that. In $100, we could just bring up all this with a 50 Mbps line again, because we don't need 10 Gbps, right? So as long as you meet your latency requirements and throughput, you're good, right? Again, SharePoint and AWS Direct Connect, Azure Express Route, and everything is seamlessly able to connect to a L3, and they can exchange information. So, okay, so let's go through the demo video. Okay. Yeah. So if you look at it, so these are the two metal servers that we are talking about. These are the real metal servers. We brought it up on demand over Equinix platform. This is on the Silicon Valley that we brought it. And you can see the even the layer 2 VLAN connectivity as well. So we programmed it. Everything is on demand, programmable. We don't need to commit upfront costs. So everything is like pay per hour. Again, these servers comes with Mellanox and Intel cards. So, and some of them comes with Broadcom. I mean, the MLX card, that's a company I worked for previously. So, all these servers, you can boot it up, enable SRIOV, attach it to VPP, and then push your data through that, okay? So here, it's a private connection that we order between AWS Direct Connect. This is again a shared port. So it's an interconnect, they call it, and 50 Mbps. So there's no redundancy here, because this is a very simple POC. We did it for this conference. So we have the Azure AWS Azure connectivity as well. And then the OpenStack is running on a metal server. So here we brought up a couple of VMs. And this is a topology that we are talking about. So we have the provider network. Basically, the provider network is towards SONiC. So that's what is going to connect you with Express Route and AWS Direct Connect, okay? So VM router comes up, and then we have VMs, which is connected to a tenant network. That's a private, right? That's local to your the OpenStack, Neutron. So basically, yeah, give me a sec. Maybe I can fast forward this. Okay, so these are the VMs. Okay. So here you see that, right? So we have a provider network and tenant network, and the subnets that we have for the tenant and provider. And DR agent, basically, this is a BGP agent that we bring it up, okay? And there's a speaker which is getting connected towards your OpenStack tenant network and the provider network. Basically, you need to have two interfaces, right? So that's what the BGP speakers. So this will have the next hop as 141. That is the IP address that will be used from the SONiC. Okay. So this is a router configuration that you will have. It will have two arms, basically one towards private, I mean the tenant network, and one towards the provider side of it. So this is a SONiC control plane configuration, right? So basically, now this shows all the network interface configurations and the BGP that we need to enable between Azure Express Route and AWS Direct Connect, actually. So basically, this control plane internally uses CephFS, right? These are the interfaces. You can see there are three interfaces, one towards OpenStack, one towards Azure. The second one is to 47 is towards Azure, and 168.47, 168.510, and 174 is AWS actually. So. Okay, this is your BGP summary. Basically, you can see those paths, right? So who are the neighbors? One is from the private subnet, I mean the BGP speaker from OpenStack. One is from AWS, one is from on the Azure side. So this is the express route configurations. So again, this is again West US. We picked it up. The reason behind this is why we picked up, because the shared ports doesn't allow you to connect to a different region, because if you have a dedicated ports, Equinix allows you to connect different regions. If you have shared ports, they only allow you to connect to the region which is closer in the proximity. I mean, you have to connect it to SV means West US, you should be able to connect all the data center. It's just not AWS. They have Oracle, they have everything actually. Whoever worked in, I don't know how many of you are aware of Equinix? Well, many, right? So you should be knowing this, right? So basically shared port has got certain limitation, but if you have a dedicated port, yeah, of course, you should be able to connect anywhere. Even between the metros, you should be able to connect. Even if you don't have that, you can have a backdoor connectivity. They have a separate backdoor network that you can configure between those edge locations. You should be able to, connect as well. So, see, this is a gateway that I don't want to get into that. So, Azure is a bit more complex, I would say, like some of the configurations, but again, this is a direct connect. Again, this is also the BGP, that they bring it up at the Azure side. And you can see that, it's already paired with the SONiC switch. This is 174 subnet. And you can see those virtual interfaces already started showing some traffic. And the beauty of SONiC is SONiC comes with, a lot of those monitoring capabilities, right? You can do an open telemetry export and push it inside your Grafana to see a real-time graphics, right? So that's what we will be doing here. And if you see here, right, the round trip, right, delay between the Azure and the OpenStack VM, right? The VM is, demo VM is nothing but OpenStack. And you're pinging the express route, you can see the latency. I mean, the round trip time is 148, which is to and fro. You get an echo, right? So that's why you see that it's half of it is less than a millisecond that we are talking about. Okay, so if you have a low latency applications which needs to grab data from multiple different cloud infrastructure, this fits the bill because it's cheaper. Okay. AWS Direct, you will see the similar numbers. Okay, so now we are going to run some hyper tests between OpenStack to AWS VM. So these numbers, because we ordered a shared port of 50 Mbps, right? We almost saturated with this. So essentially, there's no much of difference between a shared port and a dedicated port. We were able to match exactly the same results. So this is again the Prometheus export of OpenTelemetry from SONiC, and we could real-time monitor from an operation standpoint, and you should be in a position to see what's going on in your network, right? So that's what, again, this is about OpenStack VM to Azure. Again, you'll hit 50 Mbps. That's a shared port that we ordered. Okay, so the next one is so now the VM from AWS and Azure should be able to talk to each other, right? So that's a test that's getting started here. So basically you can see that, right? Again, it's heading close to the 50 Mbps. So both the sides we are able to meet. So that's pretty much the part of the demo. So what is the immediate focus that as a small startup that we are going to focus? So the area which is interesting for us is storage, right? So because Cinder has been there for a very long time, it's quite matured and a lot of provider drivers readily available, right? Chef and Pure and if you talk about NetApp, a lot of these storage providers are there. So what we are thinking is like use the SONiC VPP as a data plane and then demonstrate a cloud adjacent storage. Right? How could I have a storage at the edge and expose it to multiple different clouds? Why should I do that? Right? You may ask the question because, if you look at it as from the Spot instance point of view, right? If you have entire storage in Azure, you can only consume that storage within the Spot instances coming up because you save more than 50 to 60% cost if you go with the Spot instance, especially in case of GPUs, right? It's damn expensive, right? Think about it, right? You move the storage to the edge and make those Spot instances comes up and goes down because you don't need to worry about the state of the storage, right? And you keep pushing things back to the edge, storage at the edge. So that's one. The second one is SONiC with VPP MEMIF. Why do we want to do that? Because the work what we did is quite matured from the SRAV point of view. But if you want to chain the functions, network functions, right? It's always better to use a MEMIF actually. So that's what we are going to, this is planned for Q3. This is actual development work that we are working on. Again, what are we looking from this conference is to share the knowledge that we have. So that's an idea behind this because, community, open source community is nothing but like, you learn a lot from the community, you contribute back to the community, you share and you grow. So that's the idea behind this. So that's again, and we specialize in certain, open source projects. We have taken some of the proven blueprints and implemented in production. One of a Latin American telco, we took some of the project components that I talked about, one app, and we implemented the entire MPLS, Network Discovery and Automation, close to 20,000 devices. Today it is running in production. The same set of teams were part of that project engagement actually. So it's huge actually. So apart from that, right, again, GPU as a service using OpenStack just before me, the metal, Open Metal was talking about it. And we are pretty open for any training or workshops if somebody wants to experiment the multi-cloud connectivity. All right? So that's pretty much we have. And any questions? Oh yeah, go ahead. For Equinix? Yeah, paper use. Yeah, because everything is charged per hour actually, right? But Azure does differently because what they do is if you bring up an express circuit, right, they don't charge you, but the moment you connect, the billing starts. Because the port charges because they have to reserve a port on their side, right? And Equinix charges from the fabric connection point of view. So that's when the billing starts actually. Creating express route doesn't cost you. But the moment the circuit becomes active, they start charging you. Yeah. 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 Thank you. Yeah, Megaport, yeah. Correct. Exactly. So that's the cost benefit that, I said, right? $100 one should be able to experiment. If anyone is interested, please reach out to us. We will help you to do that. Okay, so we have all these Terraform plans, Ansible scripts. You should be able to quickly experiment if you have an account with your Equinix. Otherwise, we can even work out something to share our account as well. So as long as we recover our costs, we are good. All right, thank you.
Okay, so let's see. While Nathan is setting up here, we're going to get excited about his next talk. So Nathan is going to excite us about industry trends to hybrid environments and cloud rationalization. I think it's going to be a fun exploration for us all. And it should be exciting to see. So thanks for coming, Nathan.
All right, everyone, we'll get started in just 1 second. Let me get my slides prepped here. Yeah, so we're a new consulting company. We've got our start about last year, and what we've tried to do is get involved largely in the private cloud world. And that's largely what this talk is about. So we're going to talk a little bit about some of the industry trends. We're going to talk about some of the reasons that some of the things that people are talking about, some of the trends that we're being able to see, and we're talking about what the customers are currently trying to do. So trying to get our story so far. Where did we come from? Where did the industry get to right today? And when I was thinking about this, the question was, well, where should I start? So I'm going to start at the beginning. And the point of this story isn't so much that ENIAC was an enormous machine which required its own entire room in order to survive, but there's this constant trend. So we start with ENIAC, we move to computer rooms, to network closets, so we're always getting smaller, computers getting denser, and then we moved into actual data centers. From data centers, we actually get to cloud. This is a really big thing. Next slide, we'll be talking about that. And then from cloud, we get to the hyperscalers, from the hyperscalers to infrastructure as a service. And the punchline here is just that growth in computing power has been driven by the quest to find economies of scale and economies of scope in compute. We want denser, denser, denser. We want faster, faster, faster. We want cheaper, cheaper, cheaper. And so things have to get smaller, smaller, smaller. And this gets to the point where, so one way you can think about cloud is that it is the whole point of cloud is it's not just something that runs on someone else's server. It's the fact that in a sense you have pushed your personal compute down to zero because you no longer care about its care and feeding. You don't care about its network. You don't care about the actual physical server. That's now somebody else's problem. You're paying them for it, but then you get to use the resources itself. Brief history of cloud, right? So the virtualization is, from my perspective, because I'm old, it's a new technology because it got its start in 1999, only the last century. And then AWS introduced 2006, OpenStack in 2010, Kubernetes by 2014, and sort of our star as a service has been the latest trend over the last couple years. where you basically just have some API-driven service. So once again, the punchline of this is that all these additional layers of abstraction have been built to hide the physical infrastructure. You are far, far, far away from it, and you keep on getting pushed farther and farther and farther away from it, such that from your compute paradigm is now that you're just stitching together these remote APIs in some generic workflow. There are even workflow engines to do this for you. So you don't have to know a single thing about IP headers. You don't have to know a single thing about what the machine is actually doing. You don't care about execution stack. You don't care about heap. All you care about is stitching these APIs together. You're very, very far abstracted from what's gone on over there. So the net conclusion of that is that there's no shortage of organizations which have either lost or never had this expertise in systems and networks and the low-level stuff. Because the whole trend of the industry has been to abstract and to move away from all this, especially for the past decade. And so we've had a large number of firms which are not just cloud native, but were cloud first. So they were born in the cloud, they grew up in the cloud, and they're still heavily in the cloud. And the idea that you would want to do something of yourself, you would never ever consider, because again, your abstraction layer is so high. So that lets me segue nicely into what I'm calling the performance wheel, but I've seen this talked about elsewhere. I'm sure that if for any of you who have been around the industry for any length of time are going to recognize this pattern, that every single shop seems to go through this, and that perpetually you are being asked by upper management to lower costs, improve your serving quality, and improve your performance. What does this mean? And you go call a consultant, the consultant comes in and says, you know what, you really need to do what you're best at, and ruthlessly outsource everything else. And so you say, okay, I will outsource everything else, no problem. And so you do that, and sure enough, you really do get the cost savings. It really is cheaper to outsource than concentrate on what you're doing best. But then markets have habits of shifting, stuff moves on, all of a sudden new features are being required, and your old outsourcing company cannot keep up with this new rate of features that you are intending to push out. So your outsourcing becomes bloated and inefficient. The market shifts, which forces you to in-source because you're in search of lower cost, better quality, better performance, and you have this brand new need. I need to do something new. It needs to be cheaper, faster, better. And so you start to in-source because you can no longer do this outsource. Can we save questions at the end, sorry? Yeah, can you speak a little closer to me? Oh, I absolutely apologize for that. That is completely, totally my fault. Okay. All right, so I'll try this one, and hopefully this is a little, awesome. My apologies about the other part, the earlier part. Anyway. Messed up my performance wheel, because what I'm trying to talk about is the pattern is you outsource and then you insource, and then what happens is insourcing becomes bloated and inefficient, and so you have to outsource again, and you're in this wheel, and you're perpetually spinning and spinning and spinning around it. And every organization is at some point on this wheel. Yours, you can probably pinpoint exact where it is. It will be different for everyone. So to take this back to cloud native companies have hit this exact same performance wheel that every other company and every other technology shop has ever had. And so what are they discovering problems with? One is cloud cost, especially as you get bigger and bigger and bigger. Cloud costs move up linearly. There are issues of control, and this is actually a really big one, and people are discovering, especially in this day and age when a lot of the people really interested in AI are particularly worried about data sovereignty. They need to control their data. They need to understand who has access to data. They need to prevent unapproved access to this data, and this becomes a super, super big deal, and we're going to see it become an even bigger deal over the next year as the lawsuits start coming out about copyright and who has access to what data to train your model on. There are issues with performance. Clouds can scale, they do really, really great, but then all of a sudden you're spending $1 million and you're wondering where it's all going. There are compliance issues. You get a lot of stuff that, depending upon where you are operating, there are geographical restrictions, there are privacy requirements, and you may have a provider that claims that they are compliant with it, but can you actually survive an audit when you go to do this? And the last thing I want to talk about here for where cloud native companies are discovering problems are largely with sizes of scope and sizing. And so part of it is, one of the original sales pitches of cloud is you would spin up additional instances as you need them, and you would take them back down when you don't. And it was a wonderful and beautiful idea. The number of shops that actually implemented are surprisingly small. And so this winds up being a big deal for a lot of the cloud native companies, because now all of a sudden you've spun up this large number of VMs, and then even when your traffic is low, you still have this large number of VMs because you never bought into that, well, I should just reduce these when I don't need them. I should reduce the number that I have and then spin them back up when I need them. So Cloud native means cloud dependent. This slide I kind of went back and forth on it, including because I have to talk a little bit about accounting, so my apologies for this. But when accountants are trying to do cost estimations, what is something going to cost me next year? Costs fall into one of two categories. It's either a fixed expense or else it's a variable expense, and that's it. And we can argue and go back and forth about what qualifies about which category, and if you need some entertainment with your accountant, I encourage you to do that. But the idea of a fixed cost is a cost you spend once. So if you buy a server, you buy the server once, you exchange money once, you now have the server, it is yours forever until you choose to get rid of it. But electricity is a variable cost. You choose how often you want that server to run. So if you have it run for 5 hours a day, you only need to pay for 5 hours of electricity. If you want it to run 24 hours a day, then you have to pay for 24 hours of electricity. But that cost is variable. It depends upon how much you use it. What's the point of this? So if you look at the cost versus number of VMs, how many VMs can I fit on top of a server? And when you are self-hosting, your cost curve is largely flat because you have to pay for the purchase of the equipment, and sure, you have, if you run it 24 hours a day, fine, you have to pay the electricity for 24 hours a day, but this winds up being a fairly fixed number. Whereas if you go into a cloud provider and you want to spin up a new VM in a cloud provider, they just charge you per VM. So that means VMs themselves are now variable costs, not fixed costs. Remember, the server, fixed cost, VMs, variable costs. So the more VMs I have, the more expensive it gets, and then the fewer I have, the less it gets. The punchline of this slide is in that third part, the verses. Those lines cross. This is the key point when I'm talking about cost, is that at some magical point, and the exact number is going to vary depending upon the cost of your servers, depending upon the cost of your service, depending upon the competitive environment, and all these other cost factors, at some point, you will be big enough that it will be, your lines will cross, it will be cheaper to self-host than it will be to go out to a cloud. This is called an economy of scale or an economy of scope. The bigger you are, the bigger this economy happens to get. And that's one of the cost reasons that people who are cloud native are looking back and saying, well, I hit a certain point, maybe I'm past that point, and in order to save costs, improve performance, improve quality, it might want to consider doing something myself as opposed to letting the cloud provider do it. There are also issues of control. One of the bad things happen to everyone. I'm not here to make fun of GCP, believe it or not. I'm actually not here to make fun of the public clouds. I think they're fantastic services, but they have their place, and I'm trying to establish the boundaries about that. So there are definitely control issues. Everyone's aware that GCP auto-deleted the entire account of a $125 billion pension fund. This was Australia's superannuation fund. Now, because it was a very well-run fund, they had proper disaster recovery and business continuity plans in place, so they had enough dissimilar redundancy that they didn't just have a backup provider waiting inside a GCP, because that was all their backup stuff inside a GCP was deleted when their GCP account was deleted, but they had it in another provider, so they were able to restore from backup and get back to work. Good for them. They planned well, they executed well, they did what they were supposed to do. But again, the punchline is, when you start thinking about this, being cloud native means being cloud dependent, which means that if the cloud screws up, they've screwed you up. So you can't blame yourself for that, you gotta blame them. So yes, you can try to bound this with SLAs, but you've discovered very quickly that SLAs are very company dependent, and they're dependent upon how well your negotiation skills are when you signed a contract with that particular provider. I've gone on about performance. This is a very technical crowd, so I'm not going to spend a lot of time on this, but yes, you can have VM contention, network contention, API access contention, data gravity, and I think I already mentioned data sovereignty, which is becoming a bigger and bigger and bigger deal. There's one that I left off of this particular slide, but I just had a customer bring this up literally just this last week, which is why I haven't updated my slide, because I'm lazy. But the idea isn't just data sovereignty, the idea is compute sovereignty, meaning if you're a fund in Dubai is a tier 2 country. You are not allowed by US trade restrictions to buy more than some fixed amount of GPUs for your acceleration for your own clouds that you intend to build. So now you're in a bind. If all of a sudden compute sovereignty is a big deal, how can you outsource for this? How can you try to insource in that? You begin to see the bind that they're in, but the legacy models do not work for them for this particular instance. So this is brand new, which I just learned about this last week. I already talked briefly about some of the compliance issues. You need to make sure that your vendor is appropriately compliant. One of the ways to guarantee compliance is to do it yourself. And this way you can survive any audit, you can present to any auditor, you can go through appropriate steps, you know exactly what level of control that you have, and so you can guarantee the compliance that you need with what your compliance department says you need to do. We're getting towards the end of this. We also have an issue with sizing and scoping of service. I talked a little bit about this earlier, but what I really wanted to point out here is that if any of you have run a real-world production load, probably you've noticed it has some 24-hour periodicity to it. So there's a time of day when all your end users are up and about and are using your service, and then there's a time of day when they're asleep and they're not using your service. So you get this nice sine wave of utilization out of it. One of the issues is that that's great for production loads, but in addition to production loads, you probably also have a staging environment, you have dev environments, you have a full CI/CD pipeline, and so you perpetually have a test environment that you are always executing unit tests and regression tests and the like against, which means that your actual observed load from the computer's perspective is more like the one on the bottom there. It's jagged. It's not smooth at all. It actually varies tremendously, and this is one of the things where if you know what your load looks like, if you know what your performance looks like, then when you start to do it yourself and you want to start scoping and scaling out to better control your costs, you want the nice load case that we see in the top of the picture, not the ugly case at the bottom. And so therefore you want to export this jagginess to a cloud provider, so they have to take the risk on that, while you maintain your production load yourself, because that is nice, easily predictable, and therefore easily costable. Now, there are some negative externalities, of course, to doing it yourself. There's a lot of other expenses, a lot of other risks. The problem is that you have risks no matter what it is that you do. And so what a lot of guys are winding up doing is they want to dip their toes in the water, and so they wind up with a hybrid model. And once you have a hybrid model, then all of a sudden you're concerned about networking, you're concerned about transferring data in and out between the clouds. Data gravity is real. Egress out of the clouds are very, very expensive. And so you have some level of negotiations to go through, and you have some clever networking decisions to make and some clever systems decisions to make in order to allow this all to interoperate. But you can get substantive better cost, better pricing, better control, better performance out of a hybrid solution than you can out of going strict one or strict the other. So rationalization then ultimately does not mean no more cloud. What it really means is evolving into an intelligent hybrid strategy. There are no shortage of projects and vendors to allow you to do this. This is probably the best part, in my opinion. A lot of these are open source. If you want to take the hit and you want to do it yourself, by all means. All these technologies are available. You can deploy them. You can maintain cloud semantics, even in a private cloud environment. So you can go ahead and have API control, and you can programmatically bring things up and bring them down, and you have all the usual scripting that you would expect in order to get your environment exactly the way that you want it. So, to sort of wrap things up, the latest spin of the wheel from where I am sitting, and again, every company is going to be different. Everyone's going to be at a different point on that performance wheel, and they're going to be looking at slightly different, unique circumstances. But all of the, or a large number of the AI companies that I'm talking to are right there in the red one. They've discovered that they really, really, really like AI. They really, really, really want to invest. They're very deeply interested in this. And for all those reasons we talked about, the cost, the control, the data gravity, they really, really, really do not want to be in a public cloud to do it. They want as much control as they can maintain because they want as much security because they are deeply, deeply concerned about other people getting a hold of their data. And yes, I did use an AI to generate the image which says AI. Where do I have proof of that? It's the fact that the data center construction is at record highs. Remember, we started this whole thing just trying to get a feel for where's the industry going, why are we in data centers, and what's happening with data centers, how are we dealing with the hyperscalers, and the problem is that you can see that exponential jump. So this is real, the money is being spent, and it's getting spent here in the US. This is a largely local phenomenon. This is not necessarily an internationalized phenomenon, although multiple parts of the world are trying to go with this. A quick side note, Middle East especially is really interested in new build projects. The US seems to be much more interested in consolidation and rationalization, but once again, this just goes a reminder that everyone is in a different spot on the performance wheel. All right, so we're right to the, towards the end of the talk here, in that the ideal case is that you know enough about your workload, you know enough about your use case that you can put together the solution that you want. You build the stack that you want, and you know enough about the industry, and you know enough about everything else that you can pick and choose as to what works best for you. And this is so incredibly important. In my opinion, this is the thing that gets lost the most. Every time you talk to a vendor, yes, they have a point of view, they have something that they want to push. Every time that you have the opportunity to step back and rethink your solution, I think that you will discover the opportunity is there to lower cost, improve performance, improve quality, which is of course the overriding thing that everybody wants to do. That's what's driving that performance wheel. So yeah, vendors for every part of the stack if you don't want to do it yourself. And so I want to take just a minute or two, take a question or two, otherwise we'll call it good. Awesome sauce. Yes, sir. Only when it's 5 o'clock in the evening and I'm standing on a stage and want to be sure that I know that I'm being timed. Awesome. Thank you, everyone. Awesome, thank you. Yeah, it's a challenge because you have to break out into accounting, and usually that's really dull and boring, and who wants to listen to that? But it's good to give us absolutely. Yeah. Because like I said, it is one of those key factors that people who run shops have to worry about. Stuff lands is always
What's your name? Yuya Kuno. Okay. You are Toshiaki Takahashi? Yes. Okay. I will do my best to pronounce it. Feel free to correct me. Okay. And I may just go with your first names, or, well, is Yuyu okay, or do you go by? Yeah. Okay. Okay. And Takahashi. Okay. Or Toshiaki. Toshiaki, the first name. Toshiaki. Yeah. Sorry. Yeah. Sorry. I'm looking here, looking over there. Okay, so I'll try and say the full name, but I don't want to butcher it. So Toshiaki Takahashi. Yuyu Kuno. Yuya Kuno. Kuno. Yuya Kuno. Okay. Yeah. So ORAN Lifecycle Management. Okay, using OpenStack Tacker. Okay, so we've got about 8 minutes. Okay. I'm going to be over here also helping give you some timing guidance. So you have 30 minutes till the end of the day. This is the last talk of the day. So if you go over a little bit, that's okay. We're going to try and keep it to the 30 minutes. I have timer cards. So you'll get a sign that says 10 minutes left, 5 minutes left, and 1 minute left. And it goes yellow, orange, red in that particular order. And I'll try and do it to where it's just a couple minutes shy of the 30 minutes so that there's still time for the audience to ask questions. So I'll target about 28 minutes is when you're getting that 1 minute sign so that the audience can ask. Okay? All right. Thanks for coming out today. And we find that this mic is working best from a perspective of being able to talk and have the people hear you. This one, people tend to stand back a little bit, and it's not carrying through just nearly as much. So if you want to use this one, that would be good, or to hold it. And I'll step down here and just introduce you guys here in just a minute, and then go from there. Any questions? Okay, we're going to get started here. We're like 30 seconds shy, so we'll just lead into it. Okay. Okay, if we could have a seat, we're gonna get started with our last talk of the day. Please welcome Yuya Kuno and Toshiaki Takahashi. They're going to be here talking to us about ORAN lifecycle management on OpenStack Tacker. So thank you, gentlemen.
Thank you very much. Hello, good afternoon. I'm Yuya Kuno from NTT Docomo. I am bridge among ETNV standard, OpenStack Tacker, and Docomo development. Docomo is one of the major mobile operator in Japan and succeeded to migrate core network system to virtualization. This presentation is all-round lifecycle management on OpenStack Tacker to extend OpenStack use case with resolving LAN challenge as next activity. As you know, many operators, including Docomo, already virtualize core network system using OpenStack, and the operator got the merit of the virtualization, so many operators are interested in virtualized LAN as the next target. This is a joint presentation with Docomo as user and NEC as integrator for commercial to present VLAN challenge and solution. In this presentation, I would like to show advancing toward VLAN challenge, Tacker solution, and user scenario by Tacker. LAN has its specific challenge to meet a requirement. First is LAN specific performance, such as multiple execution of coding process that does not allow delay. Second is operation and management for small and high distributed system, such as some 10,000 base stations in nationwide, and very small footprint and very small energy limits. Third is cost, such as the dedicated equipment was already low cost with parts reduced to minimum of the redundancy and hard disk. Goal of the VLAN is low cost, high quality, and further automation, while dedicated base station optimize LAN use case and requirement, including performance, footprint, and energy operation and maintenance. Mobile operator already got NFV and virtualization merit, so many operators want to get advanced virtualization merit by extending LAN domain. LAN is very big scale and distributed system, so NFV and virtualization merit can be maximized. In this 10 years, right side is NFV and virtualization merit. NFV and virtualization mobile network cost reduction using cost server from dedicated equipment, and new formation to avoid emergency maintenance by auto-healing. This aspect is big impact on operators' cost and high quality service of application using resource pool from Act standby. This means one redundancy and auto-scaling to extend capacity. Last one is automation. Automation deployment using descriptor and remote work by lifecycle management. These are NFV and virtualization merit for this 10 years. Next challenge for VLAN is further cost reduction, further high quality, and further automation by NFV technology and OpenStack technology. Because LAN equipment large-scale distributed cloud that increasing to order, we are facing new challenge. When NFV and open infrastructure technology resolve these challenges, operator can get more merit, reducing cost, power and on-site work, intelligence and automatic operation, maximizing NFV and OpenStack merit across multi-domain from LAN to core. Towards VLAN, operator want to improve our operation of LAN network. In typical operator has network operation system, network operation center NOC to monitor nationwide equipment and some building to accommodate core network system and base station in each edge site. Currently, operator need to rush to go to base station if base station is failed. This requires very big cost to maintain formation of operator and spare parts of the base station. In addition, until an operator arrives to repair the system, only one system will be in operation, resulting redundancy, reduce the quality. Therefore, operator want to change this operation and quality using virtualization technology to avoid visit all large-scale distributed cloud to maintain them, like some 10,000 sites. So we need to change operation and of cloud drastically. NFV and OpenStack technology can help remote work by lifecycle management, like instantiation, healing, scaling. And the merit is very big for operator to reduce on-site urgent maintenance and unified operation by virtualization and cost server. But still there are some on-site work like a change configuration, check quality, increase, decrease hardware. Operator want to resolve these challenges to reduce on-site work. NFV already improved on-site work from 58% to 20-30%, but operator want to improve more on-site work to reduce like a 5%. This is the idea of the architecture toward VLAN. Docomo already succeeded to use NFV system, so Docomo tried to realize VLAN with OpenStack Kubernetes framework and reusing existing specification to maximize NFV and OpenStack merit. According to NFV, operator can manage both container-based network function by CISM, like Kubernetes, and VM-based network function by VIM, like OpenStack, in same platform. Operators still need to operate both VM and container from characteristics and investment perspective. On the other hand, VM and container are big gap, concept level, operation, and packaging. This is one of big challenge to extend virtualization platform to extend LAN domain. In order to unify platform, generic VNFM, path, and generic EM are important to fulfill this gap between VM and container. And the gap between vendor product also need to resolve. OpenStack Tacker is a key component to realize LAN and resolve VLAN challenge to unified platform. This is just a recap of the OLAN. OLAN is the G-Node-B specific internal design in mobile network. Mobile major standard is 3GPP. This specifies G-Node-B as base station, but it does not specify platform and intelligence. Therefore, another SDO, this is called OLAN, Alliance, specified fourth aspect, which is missing part in 3GPP. First one is connectivity of RU and DU. RU means almost antenna. DU means equipment of base station, called open front hall. Second is automation for radio parameter, like a power wave and tilt degree. These are called LIC, LAN intelligence controller. Third one is virtualization for LAN. This is the main scope of today's discussion. OLAN Alliance want to virtualize base station to improve cost reduction and operation automation. But Radio has new equipment to connectivity between DU and RU that is directly connectivity without any switch to avoid jitter and delay. This is a very specific condition for cloud infrastructure. OpenStack and Tacker are called O-Cloud in ORAN. O-Cloud support virtualization and cloudification of LAN equipment VDU and VCU, and support automation of the operation with RIC as shown this slide. This is the OpenStack Tacker VLAN ecosystem. Tacker accelerates NFV specification across SDO, HE, ORAN Alliance, of course OpenStack, and ORAN SC. Now VLAN domain has these 4 big SDO. It specifies virtualization platform by Beam CISM, VNF manager, and NFV orchestrator. ORAN also specifies SMO and O-Cloud. OpenStack and ORAN SC are open source to use these standard specifications. Tacker is NFV compliant VNF manager, and Tacker downstream to ORAN SC to realize VLAN. These activities are very interesting for operator, and Tacker makes avoiding fragmentation in mobile industry. So this is very key open source components. This is the challenge of the ORAN domain. This is a lesson from core network NFV development and operation. First one is interface customization. This is very risky for keeping backward compatibility and future interoperability. Tacker supports this interface as open source. Second one is upgrade procedure of both NVI and VIM. It means infrastructure of the OpenStack. This is more complex. Tacker can migrate VNF when upgrading NVI infrastructure and Beam OpenStack. Specific management for each VNF does not scale, neither economically nor in operational terms. Tacker is generic VNFM for various types of VNF. So these 3 types, Tacker can support these challenges. Additional challenge on VLAN, SMO introduced and its capability. We have many issues: unified lifecycle management, multi-vendor O-Cloud, SMO OSS migration. Tacker can support unified operation for multi-vendor VNF and O-Cloud in virtualization environment. Second big challenge of the VLAN is O-Cloud design. Unified platform across core network and LAN domain. Unified platform for multi-vendor application with accelerator, and addressing power and energy constraints. Tacker can support these various O-Cloud configuration, including small footprint and accelerator aspects. Last one is virtualized LAN application. The most important is decouple of the software from hardware, including acceleration card. Tacker can support lifecycle management for LAN application with these strict accelerator and open front hole connectivity that is directly connectivity between DU and RU. These are big challenge of VLAN, and Tacker should resolve these issues.
Okay, hello. So my name is Toshiaki Takashi from NEC, so integrator for telecom companies. So I personally work as a OpenStack Tacker community's core committer. So today I want to explain the Tacker's capabilities or some organizational activities related to run activities. Okay, so first, maybe this is already shown by Yuya. So yeah, our Tacker's purpose is adapt the existing telecoms virtualization system to also run so radio area network domains. And one big activities is attending the ORAN SC communities, ORAN software communities community. So this is also open source community, and so this is partnering with the ORAN Alliance, ORAN Standardization, and the Linux Foundation. So these two organizations create this open source community, ORAN SC community, to support the software development for the RAN domains. And maybe you can see the Tacker's mark. So yeah, of course, Tacker. So we are already attending these communities, and StarLink S is also adapted as a reference software of the ORAN-SC. So from organizational perspective, so upper side is standardizations organization. So left side is ETSI. So ETSI NFV is maybe this is one important target of the OpenStack. I believe so. So yeah, OpenStack is so some OpenStack project work for the telecom operators, telecom use case, and such activity is based on the ETSI NFV standardization. And so today's main topic, ORAN side. So RAN side is also creates the ORAN standardization, and as I said, ORAN Alliance is created the ORAN software communities. And of course, HNFE and the ORAN Alliance has already have some collaboration activities. So in order to adapt the existing NFV side discussion result to new RAN domain. So there, of course, there is some collaboration. And as I said, HCA has some feasibility discussion with OpenStack. And the ORAN also have some feasibility discussion with ORAN SC. So as Tacker's project members, so our idea is we have some new collaboration with ORAN SC. So these two communities direct collaboration as open source communities. So we believe this collaboration so accelerates some feasibility discussion or realize the actual telecom operators requirements achievement. And of course, we are joining many events to appeal such activities. So these are Plug Fest events. So this event is how to say? So in this event, the many vendors test some interoperability of the many product. And the OpenStack Tacker was attending this event and shows some demonstration. So to appeal the interoperability. Okay, and from now I want to explain the Tacker's functionalities perspective, capabilities perspective. So Tacker supports LCM APIs defined in HNFV. What is LCM APIs? For example, instantiation. This is very simple, maybe easy to understand. So just deploy the application. So actual operation is first creates the virtual resources, so virtual machine creation, container creation, and after that, application configuration is also required in order to start the service. So such virtual resource deployment and the configuration application is instantiation. And the termination is stops the application. So yeah, just remove the virtual resource, machine resources or container resources. And another important LCM is healing. So of course, sometimes the virtual resource become failure. So if so, of course, telecom operators should resolve the issues as soon as possible. So such operation, so such resolve operation is called healing. So if telecom operator sends a healing request, then the failed virtual resources is so typical operation is remove the virtual resources and creates the new resources and configures the application again. And so existing operation is moved to the new virtual resources. That is called healing operation. And the SCaLE is more maybe easier to understand. If the resource is not enough, then increase the resources. So that is a scaled out. And if the resource is too much, the resource should be, so some of the resource should be removed. That's called scaled in. Yeah, so these are typical LCM. So Tacker's purpose is expose the unified one simple API to manage the many types application and the many types platforms. So telecom operator sends one unified API to manage so many types of application, many types of platforms system. That is the purpose of the OpenStack Tacker. So in order to achieve such a requirement, we have the two important mechanisms. One is the infra driver mechanism. So Tacker has the many types of infra driver. And so for example, OpenStack infra driver can send some OpenStack operation, such as virtual machine creation, virtual machine deletion, virtual machine configuration. And the Kubernetes infra driver can send some container creation request, pod creation, deployment creation. Such request is, so such operations is from the Kubernetes infra driver. And currently Terraform is also supported. So yeah, OpenStack Tacker can support the Terraform. So if telecom operator sends some one unified API, Tacker is, so of course Tacker manages the relationship between application and the platform. So Tacker can automatically select the platform and send the so proper request to the platform. So this mechanism is called the infra driver. And also application side needs a some mechanism. So that calls management driver. So for example, if there are two types of application, one is VNFA, second is VNFP. Then Tacker, so this VNF, so application vendor can register their own management driver. And one typical management driver's role is configuration of the application. So if Tacker receives, for example, deployment API, so instantiation API, first, Tacker creates virtual resources using infra driver, and after that, Tacker automatically selects the VNF. So this VNF's management driver, and this management driver including the implementation of the, for example, application configuration. So Tacker sends such application configuration to the deployed virtual machine or deployed container and so on. So these two mechanisms is important to support both of the multiple application and the multiple platform. And also another important mechanism is also required. That is for fault and the performance management. So in order to so the final purpose is auto-healing and auto-scaling. So detects some failure or detects some performance abnormal, then telecom operator want to heal. So if failure is detected, we want to heal. If performance abnormal is detected, telecom operator want to scale. So such auto-healing and auto-scaling is one of the important telecom operators' requirement. And in order to achieve this auto-healing or auto-scaling, the monitoring is very important functions. And one famous monitoring tool is, for example, Prometheus. So if telecom want to use Prometheus, so of course Prometheus can monitor the virtual machines metrics such as CPU usage or memory usage. Prometheus can monitor the containers CPU, containers memory usage. But that is just a containers usage, just a virtual machines usage. So if the Prometheus detects some abnormal of the virtual resources, then Prometheus can send such alert to first send alerts to the Tacker. Then Tacker can map the such virtual resources abnormal or failure to applications. So VNF's failure or performance abnormal. So finally, Tacker can raise a alarm of the application, alarm of the VNF to upper orchestrator. So what application is currently failure? What application is currently performance abnormal? So that is another important Tacker's role and another mechanism. So such Prometheus plugin, so external monitoring plugin is another important mechanism. So in conclusion, these three mechanisms are very important for the telecom operators. So this mechanism can resolve the many challenges of the telecom operators. So for example, so interface customization or so some specific management for each VNF, so many types of the VNF. As I said, Tacker can provide a unified API, and this is another important aspect is this is open source, of course open source. So many application vendor can release the actual VNFM's source code, and they can understand the details of the specification of the VNFM. So they can create their applications, some package for the OpenStack Tacker. And so this multiple VNF support and strict applications LCM. Strict means so open front haul is one of the very typical specific VRANs application. And some VRAN application needs accelerator support in order to high performance. So these are very strict requirement of the application. So, but if Tacker's management driver can use, so this application vendor can create the management driver in order to achieve such strict specification of the runs application. So this management driver can resolve these two, so multiple type of the VNF support and strict application support. That is possible using the management driver. And finally, infra driver can resolve the cloud-related challenges, so such as many cloud operation. Upgrade is a difficult and important operation. So this can be supported by infra driver. And most important point is various type of cloud can be supported using infra driver. So various means, so some, for example, some Kubernetes can only provide low performance, so without accelerator, just a Kubernetes cluster. That can be, that can provide just a Kubernetes capability, but some application needs the accelerator or some other hardware in order to achieve the high performance. So in some cases, so there are two types or more types of the cloud. So such multiple type support can be supported by infra driver. So only high performance application can be deployed on the high performance cloud. So such mechanism can be achieved using infra driver. Okay, so these are capabilities, functionality or capabilities perspective. So finally, I want to show the use case scenario. So these are typical VRAN use case. I explain the details later slide. So first, the first scenario is deploying Tacker on cloud. So what is the meaning of this scenario is, firstly, of course, cloud platform preparation is also, of course, required. So the precondition is some cloud platform is prepared. By the way, in O-RAN SC's community, StarlingX is reference software. So for example, StarlingX based cloud is deployed, so prepared. Then Tacker is separated one component. So we can deploy the Tacker component on cloud. And OpenStack has a very strong installation mechanism called OpenStack Helm. So, and of course, Tacker already creates the OpenStack Helm's image. So, telecom operator can install the Tacker using OpenStack Helm. Then, OpenStack Tacker installation is completed. Then, OpenStack Tacker can provide some unified interface to upper orchestrator called, so for example, called SMO. SMO is the orchestrator of the O-RAN system. So this SMO can send the unified API to manage the various type of the applications. And also Tacker can provide the FM, PM, so fault management and performance management feature. So this scenario is, so first, SMO executes the instantiation operation to the Tacker. Then, as I said, Tacker creates the virtual resources and application configuration. And at the same time, monitoring tools such as Prometheus. So Tacker can register the required configuration of the Prometheus. And of course, Prometheus starts the monitoring of the application. And if this monitoring tool detects some application failure or abnormal, then sends the alert to Tacker, and finally sends alarm of the application, send the alarm of the VNF to the upper orchestrator. So these are typical scenario of the virtualized RAM. And the important point is this is already implemented. Development is completed. So we, of course, we and you can use this capability now. We already provide the Tacker's software to the OpenStack communities. Okay, so that's all. So conclusion is Tacker is evolving to advanced management of both telecom core network and the virtualized RAN network with other standardization or open source communities organization. So we already achieved the advanced management by fault management, performance management, and we work with many SDOs such as HNFE and ONC and SONiC X, and I believe that Tacker can accelerate the virtualized RAN domains virtualization activities. Okay, that's all from my side. So thank you so much.
You've got Kubernetes there, and Kubernetes can respond and do stuff that it can scale horizontally and vertically. But it sounds like you use Tacker to do that and not Kubernetes. Or maybe do both?
This is my personal opinion, but maybe there are some cases. Of course, Kubernetes can Kubernetes itself can automate scaling or automating healing. But in telecom case, some difficult situation. Difficult means for example, it might be failure in near future, but currently not. There are no effect. But some upper orchestrator can detect such situation. Then upper orchestrator can send the request to healing before actual failure occurs. That is one of the use cases. Yeah. Yeah, one SMO project. Yeah. Yeah. Yes.
Thank you very much. Okay, so that was our last talk for the day. I want to say thank you to all the speakers who have actually helped contribute to such a wonderful day here at OpenInfra. As a reminder, there is the OpenStack 15th birthday celebration at Der Wolf. That's in half an hour from now, so that starts at 18:30 or 6:30, depending on whether you like which time you prefer. That Der Wolf is at 72 North Fair Oaks. If you want to figure out how to get there, you basically walk out these doors to Green Street. Yes, I know it's raining, but enjoy the rain. I come from the desert. You should just enjoy the water while you have it. Go out to Green Street, walk about a quarter mile down to your left. You'll hit Fair Oaks. When you get to Fair Oaks, take a right, and it's about a quarter mile up, just over Union on the right-hand side of the road. So we look forward to seeing you there. Thank you so much.